Yo, we did it. We did it, chat. Fantastic. Hello, everyone. Welcome to Twitch Learns CS. What's up, Trailmix? We did it. Finally fixed. Is the chat box working? Well, I'm at it. Yes, it is. Look at me. Okay, fantastic. Hello, everyone. Today is a very special day because today is the very first installment of our Twitch Learns CS, Twitch Learns Computer Science channel. The very first class we're going to give. And what a class we have today. So, today we're going to be talking about two topics. So we're going to be talking about virtualization, and we're going to be, in the second time, we're going to be talking about VPNs. Originally, I wanted this class to be dedicated to VPN technology alone, because strangely enough, when I asked some family, so they're not necessarily very technical people, they're not tech heads, but when I asked them, what kind of technology would you like a course on? What would you like to learn about? What is something that you wish you had the tools to understand what was going on from in any kind of computer science field? Very often, so sometimes people would talk about 5G, but the reality of it is, as long as we tell people that 5G is not dangerous, the rest is fine. However, a topic that came back quite often was actually VPN technology. And at first I was a bit surprised, because to me, VPN technology is pretty niche, at least from my perspective. I used to believe it was something rather niche and something that most people would just consider not particularly useful. But actually, I've been told that a lot of people are interested in VPNs because they're being sold VPNs constantly, right? You have all those sponsorships, all of those, NordVPNs, ExpressVPNs, and stuff like that. And, they claim that they can protect your privacy and all of that. And a lot of people would simply like to know, well, what the hell is up with that? What does it mean to use a VPN? How does it protect my privacy? And please explain that to me like I'm 5. Like, I don't know anything about computers. So that's what we're going to attempt to do today. We're going to try and explain what VPN technology is all about. We're going to try and sort of give you a simple perspective on the topic, so we're not going to go too technical, and try to divide a few use cases for VPNs, right? So the first approach we're going to have is we will talk a little bit about the technicality of VPNs once we get to it, because I believe that is something that is necessary to understand the core principle. I will use a lot of analogies to make sure that this is digestible. Then we will explain the purpose of commercial VPN, which is, VPN is actually a rather simple technology, and then a lot of it has to do with how you actually use it. So depending on how you're going to use a VPN, you're going to have much different results. And so we're going to have a look at commercial VPN specifically, so essentially the VPNs that you are being sold, your ExpressVPN, NordVPN, ProtonVPN, and all that jazz. We will also, if we have the time, I'd like to make the distinction between that and something that's called a web proxy, which are not the same thing. And finally, we will end with how we use VPNs in an enterprise setting. So so that might seem a little scary, but in reality, it's even more simple to understand than the commercial VPN. So if we understand how a commercial VPN works and how it's useful, we will have no problem understanding how an enterprise VPN is used and for what purpose. However, when preparing this class, I also realized that I wanted my student that's going to be joining us in a little bit, I want them to have the ability to test out the technology, because it's one thing to talk about a technology and to explain how it works. It's another to, get our hands dirty a little bit. And I believe that practice is really important in our line of, in computer science. And so I prepared a lab that I will explain on later. But I also realized that, for us to do any kind of labbing, we will most likely have to do some virtualization just for our labs to be able to run, just for us to be able to do our practice, to practice a technology. Just for us to be able to practice something we learn, we first need to understand how virtualization works. So this is why at first today, I will sort of go over the basics of virtualization technology and explain why it's so powerful, what makes it versatile, how is it useful to regular people, how is it useful in enterprise also, because the main purpose of virtualization is enterprise, but it's not its sole purpose. It can be very useful to people like you, even if you're not necessarily computer scientists, even in something as simple as you want to renew your I don't know, uh, Photoshop free trial, for instance, and like Photoshop keeps telling you, well, no, you can't do that. You've already installed it on this machine. Virtualization can help you with that. So virtualization is a very versatile tool that we first need to unpack if we want then to be able to run our labs. Um, so we will get started any moment now. With me today, we're gonna have Trailmix. So let me ask him if he is ready. Okay.
Hello.
Hello, Trailmix. Can you hear us? Me?
Yep. Hold on,
Yes?
let me just mute stream.
Okay.
Okay.
Okay, so how do I call you? Do I call you Trailmix?
Up to you.
I
Hold
mean,
on.
you tell me. It's your name. Okay. Trailmix. Before
Yes.
we begin, can you tell us a little bit about yourself? Like, um, why are you interested in those topics? Who you are? Maybe how old you are. I think a lot of people I'd like to know that. And also what you're hoping to get from this course.
Well, I am 15. I first started getting into computers when I was 13 and a half, 14, because my brother promised me that for Christmas he would get me computer parts and then I would build my own computer. So at Christmas, I got all the parts, I built my own computer, and I was very interested in how it worked, and that just opened the door to me for the whole entire computer world. And then later, when I realized that I loved this kind of work, just building a computer, knowing how it works, knowing how to fix it, I realized that there are many jobs out there that could be useful for that.
Yeah.
And so then I started looking into computer engineering. But then I realized that from what I understood, that was more so building a processor, building a graphics card, not
Hmm.
really the kind of thing that I was into. Later on, I realized that was a part, a service in French, network engineer. And then that's when I realized that they were the ones who just set up the server, set up the software to put on the company's computer,
Yes.
things like that. And I realized I wanted to do that kind of stuff. And so ever since, I've just been trying to learn a bit of what these people do.
Yeah. What have you learned so far?
Not much actually, surprisingly enough. Well, like I said, I know how a computer works. I don't mean like I know how data travels through computer. I know how to build a computer. I don't exactly know all the technical stuff about a computer. I can build one. I know how a VPN works. I know that virtualization exists, but I don't know the specifics of how to run a virtualization or a lab or anything like that.
Okay. And so I'll be really curious later on. I'll ask you what you know about VPNs because that's always so. As an instructor, I always find it very interesting to have students who have some knowledge on a particular topic to ask them to sort of explain what they know or sometimes what they think they know.
Yeah?
It's particularly interesting. So we'll get to that later.
Okay.
Um, what you mentioned labs. Yeah, so for the other viewers, labs is in the computer science setting. Labs is what we call, practice work. Is we call that labbing. Is you deploy a lab, a personal lab, for instance. You deploy a lab and you test things out on the lab,
Okay.
right? Um, is there? So I'm curious to know, like, what are you hoping to get from this class? Is there something in generic that you're hoping to learn, or like maybe top, like something specifically that you'd like to learn?
I guess just the general knowledge of how these things work, how I can use them to my advantage, how
Yeah.
to avoid suspicious looking sites or authors also.
Well, that is mostly just a matter of knowing the big names, essentially. So,
Okay.
for instance, for virtualization, you can't go wrong with VMware,
Okay.
fundamentally,
Yeah.
right? Okay.
Okay.
So, if you don't have any questions, I believe we can get started.
And that I
So,
do not.
okay. So, let me share my screen with you real quick. Mm-mm. Okay. Do you see my screen? Do you see the whiteboard?
Yep.
Okay. So, let's start with virtualization.
Okay.
So, first of all, what do you know precisely about virtualization? Like, you said you've heard about it, but like, what does it mean to you? What do you think it means?
Generally, it can be used as a second OS or as multiple OS on one PC, and that it can, as
Go
you were
on, go
saying,
on.
it can be tested, I guess.
Test it. How so?
Testing out different programs to make sure that, like, if something goes wrong, it won't delete a certain file that is really important.
Right. So, some form of isolation.
Yeah.
Right. That's actually a pretty good introduction to virtualization. So, before we get to what it does, I guess the real question is, what's the initial problem? So, let's take our example. Like in our specific case, what we want to do later on in the class is we'll want to, I'm just giving you a quick preview. We'll
Yeah.
want to have a system where we have two computers running. So one of them would be Linux, one would be running Windows 10, and we'd have a router or firewall running pfSense. I'll go into more details as to what those are a bit later
Yeah.
on. But those are three different operating system or OS.
Okay.
So I suppose you're already familiar with what an operating system is.
Yep.
Can you explain that to us a little bit?
Oh God.
If in simple terms.
Uh, well, I guess it's the thing that brings everything together. It's the platform which is the most needed. Because without an OS, you can't really do anything.
I like that you called it a platform. That was pretty good. Can you really not do anything without an OS? Because obviously an OS has to start somewhere, right?
Yeah.
Okay, for instance, when you open up the BIOS or the UEFI menu,
Yeah.
UEFI setup, do you need an OS for that?
No, because that's already in the motherboard.
Right. So an operating system like Windows or Linux or Mac OS is it's not the lowest level, but it's, as far as the end user is concerned, it is the lowest level software running on the computer. It's a piece of software at the end of the day, right?
Yeah.
Right. It is the lowest level software. So that means you have your regular computer, like this one here. You have your
Yeah.
regular computer. You want to be able to interact with it. But obviously, you're not going to manually interact with each component. Like you're not going to manually interact with like the motherboard, the CPU, the graphics
Hell
card. No,
no.
you'd like something that you'd like a piece of code, a piece of software that already coordinates sort of all of these hardware components, right?
Yeah.
Right. This is what the operating system does. It gives you a baseline to manage all the components of your system. So
Okay.
the most obviously, what is the most popular operating system?
Either Windows 10 or Mac OS.
It's obviously Windows 10 by far. Do you know
Yeah.
why? I
Be-
mean,
because
not
it's
specifically Windows 10, but like Windows in general. Why Windows?
because it's more well known. I guess it's less expensive and it's more open. It's less restricted.
So hold on. Can you repeat that for us? I don't think
Well,
I heard you very well.
well, in a sense, it's cheaper
It's
than getting
cheaper.
Mac. Uh,
Yeah, right. Okay. What other operating system are there? So we have Windows. What else?
uh, Mac,
Mac
Linux,
OS, yeah.
and then those are the only three I know.
Mac OS, Linux, right. There are a few others. One of them
Uh,
we're actually going to use like FreeBSD.
okay.
BSD. We have Solaris as well. And I think this is a good place to stop. But like the three main ones would be these three.
Yeah.
The three more popular ones. Okay. And so you're saying Windows is cheap, right? You're saying it's cheap. You're saying it's what else did you say exactly about Windows?
Well, it was less restricted because, from my knowledge, with Android OS and iOS,
Ah,
there's
you mentioned another one, a couple others. So there is also
Android and
iOS and
Linux.
yeah, and Android. Can I run Android on my PC?
You can using an emulator.
Right. But like can I install Android
You
directly on
can.
my PC as an operating system natively? Bare
I
metal.
think you can.
No, you can't.
No,
Do you know why? We'll get
because
into that. But it's a
okay.
matter of the architecture of your CPU,
Oh, okay.
right? So you have X x86 is what you usually find for desktops. So,
Yeah.
for instance, Windows, Mac, Mac OS, Linux, FreeBSD, Solaris, they all run on x86. And then you
Okay.
have ARM processors, which are usually found in, which are mobile processors.
Okay.
And so Android, for instance, will run on ARM. iOS will run on some ARM. Now, x86 is a lot more standardized than ARM. You have because ARM you have like a bunch of standards for it. It's not quite as simple. Like you can't just install Android on iOS, even on an iPhone.
Yeah.
Not just because of the sort of restrictions that Apple will put in the way, but also from a technical perspective. Like it's not necessarily the correct chipset. It's not necessarily the correct CPU architecture.
Yeah, it isn't compatible in a
Right.
sense.
Right. Exactly. So
Okay.
we already know a bunch of operating systems. That's great. So let's continue with my question. Why is Windows the most popular?
Because it's also less restricted.
That's
I
restricted. How
think
so?
because Android, from what I know, it is an open source base, so we can modify the code, which is actually how a lot of Chinese duplicate of iOS run. It's just an Android OS modified to look like iOS.
Right. That's correct.
And then I think it's the same deal with Windows because sometimes we can see a lot of personalized computers from Asus or Acer.
Yeah. What about those?
Well,
Are they not running Windows 10?
they are, but it's more in a personal sense. It's modified so that it would work with the Asus technology.
Okay.
Yeah, I shall be right back. I'm just gonna close the window because it just
Okay. No problem. Let me clean this up real quick.
Okay, just a little heads up. If I disconnect for more than 5 to 10 minutes, it is because we turned off the internet because it turned white outside from the vein.
Wow, okay.
Yeah, so just a little heads up for you.
Okay, no problem. Thanks for warning me.
Yeah.
All right, so Windows is in fact the most popular operating system. That's a fact. And you said it's cheaper than Mac OS.
Yeah.
You said it's less restrictive than Android and iOS. Is that
Yeah.
correct?
Oh, just I guess less restricted than Mac because Apple likes to personalize a lot of stuff and make it to their purposes so that it can't change at all.
Right. Yeah. Mac sure likes to, Apple sure likes to do that. That's for sure.
Yeah.
Well, turns out that as far as Windows is concerned, there are two markets for Windows. The first one is the sort of personal computer Windows market.
Yeah.
And where Windows has an advantage there is the fact that it's two things, twofold. First of all, it's pre-installed on every computer you can buy on the market, right?
Okay.
So you have
Yeah.
John Smith wants a new laptop. He goes to Best Buy. He buys a laptop. It already has Windows. He's been using Windows for like 2 decades. He knows how to use Windows. He's used to it,
Yeah.
right? So it's like it's because it's installed by default. But then there's the question, why is it installed by default?
Is
Well,
it because
because
it's also simpler?
that's arguable. You know, you ask people who have been using Mac forever to move on to Windows, they don't know how to do that. It's simpler
Yeah.
simply because we're used to it.
True. Fair enough.
So one advantage Windows has is that first of all, compared to Mac, well, I don't okay. So in the sense of personal computers,
Yeah.
Windows computers are always going to be cheaper than Mac than Macs, obviously,
Yeah.
right? So as far as the economics go, it means that more people are going to end up with a Windows computer than a Mac.
Okay.
That's the first thing. Also, Windows, you can install Windows on pretty much any machine that's an x86 machine, right? Like
Yeah.
any desktop can run Windows, but not any desktop can run iOS because, like can run Mac OS. Because, like you explained, Apple really likes to lock their software with their hardware as much as they can. Obviously, you can, with enough knowledge, you can install Mac OS on like a desktop that you would have built yourself, but that takes quite a bit of knowledge, right?
Okay.
John
I just
Smith isn't going to do that.
I have to disappear once more. Sorry, I just have to close my dad's window too.
No problem.
I have once more returned.
Right. So we were saying that with enough knowledge, in theory, you could install macOS on any desktop, but that in practice, it'd be much simpler to just install Windows.
Yeah.
Right. Okay.
Can it be
Um.
vice versa with the Macintosh computer? Can you install Windows onto a Mac, for example, with enough
I
knowledge?
believe so. Yes. So from a fundamental technical perspective, and as far as I know, there is nothing that like physically restrains you from doing that.
Okay.
I believe I have seen people do it as well, but I haven't looked into it.
Okay.
Okay. But so far you've mentioned mostly Windows and Mac. What
Yeah.
do you know about Linux?
I guess it is the open source OS mostly.
Right. So you were talking about cheap. Well, how cheap is Linux?
Isn't it free?
It is.
But don't you have to sort of like personalize it yourself?
So it's rather that you can personalize it, but you don't have to.
Okay.
In fact, later on today, we will be running a Linux distribution. So Linux is kind of weird in the sense that there is no one Linux operating system. Linux is a
Yeah.
Linux core, and then you have a because it's open source. Anyone is free to implement it in any way they want, and those different implementations are called distributions.
Okay.
And so you have multiple branches of distribution. You have the let's see, you have the Red Hat, you have Debian, you have, I believe, Fedora. I'm not super well versed on the distribution tree of Linux. I mostly use Debian myself, or Debian based. So you have Debian, which is like one of the roots, like one of the root distributions, and then it
Okay.
sort of you then have multiple, like Debian is like an entire family of distributions. You have, for instance, the famous Ubuntu. If you've ever used Ubuntu, it is Debian based.
Okay.
You have Pop! OS, which is technically Debian based, but even more specifically is actually Ubuntu based. So today we're going to be using Pop! OS because personally I think it's very good. Um, for servers, so for instance, if you want to deploy a Linux server, and you might have plenty of reasons to want to do that, you could run it on Ubuntu. In fact, Ubuntu servers are a thing and
Yeah.
very popular thing because we'll get into that. But let's say the technically more best, let's say, in my opinion, the one I like working with the most is actually CentOS, which is a different branch from Debian. So like you have different like the Linux core is the same, but things like this, the package manager are going to be different. Things like the service manager are going to be different.
Yeah.
So you have a bunch of things that are tailored differently for each distribution, and it's a
Yeah.
whole entire mess. And the best part about it is not only is it a whole mess, but it's a ever changing mess because everything is open source, almost everything,
That
right?
has to be terrifying at some point.
It can get daunting, but usually the way it works, in my opinion, is that if there is a Linux distribution that you like using personally, you just stick with it. There is no wrong answer. You will like I've seen really interesting videos, especially like you also have penetration testing Linux OS. So penetration testing is sort of professional lingo for professional hacker.
Okay.
So if you want to be a pro hacker, you don't put that on your resume. What you put is that you're a penetration tester.
Okay.
And so you have Kali Linux, which is very famous. I think you have Parrot as well, but that might have. I think it's. I don't want to say shit about Parrot. I'm not actually certain.
Okay.
But Kali is by far the most famous one. But if you actually ask if you ask penetration testers what distribution to use, some of them might recommend you some distributions because some distros come with a lot of software already pre-installed, which is really
Okay.
nice. Like for instance, if you need something to start sniffing Wi-Fi packets, well, you're
Yeah.
gonna have to install a package for that. You're gonna have to install an application for that. Well, some
Yeah.
distros come with that natively, so it would make sense to go with those, but you don't have to. So even if Kali Linux is specifically tailored, for instance, for penetration testing,
Yeah.
well, you could very well do penetration testing with Ubuntu. Like you can, it just works.
Okay.
So yeah, Linux is like a whole entire world of how things work. But then why is it if Linux is literally free and honestly not that much harder to use than Windows, right? Because I think a lot of it is literacy, is getting used to the operating system you're using.
Yeah.
Why do you think it is that Windows is so much more popular than Linux?
For me, I guess would be around the time that they were both created. Which one was the first one? Which one has been here longer?
Technically, I actually don't know the answer to this question. If you really go back to the root, they both have a shared root, a shared, I don't want to call it a core, but a shared root that's called Unix.
Okay.
So Unix was like one of the very first operating systems, and then when it ended up like you if you let's check it out. All right, let's go on Wikipedia, because usually they have pretty good stuff about this. So Unix, what can we find about Unix? A family of multitasking, multi-user computer operating systems. So it's a family of operating systems. And if we look at this chart, we see okay, there we go. What operating systems do we have? So we have Unix here at the top.
Yeah.
And then we have different versions of Unix. And let's see, we have Solaris that I have mentioned. We have Mini X. We have Linux. Yes, we have FreeBSD that I mentioned, BSD, Dragonfly, NetBSD. Let's see. Where do you see macOS?
Linux, in between Linux and FreeBSD.
Linux. Yeah, right here. You're correct. macOS. That's strange. I believed Windows. Oh, maybe Windows is like a Unix-like system. Oh, okay, yeah, that makes sense. So Linux is actually a Unix-like system. It's not a Unix system. It's not based on the Unix core.
Okay.
But what's really interesting is that I believe there was an older version of Windows. Was it? Hold on, let us check this out, because I'm really curious. Actually, no. What was it? Wasn't it? Unix-like, GNU, ARPANET. That's strange. So from what I remember, again, I'm not like, my Unix history isn't perfect, but from what I remember, there was the very first versions of Windows were actually Unix based, and then they moved them away from Unix.
Okay.
But like Unix is, think of it as like Atom. It's like the very first operating system that everything else came from, pretty much, more or less. But what's really interesting is that if you look at this, you see you have Linux and you have Mac OS on this chart.
Yeah.
So the really cool thing is that Linux users will be more comfortable, usually, kind of. I mean, there is a lot of similarity between Mac OS and Linux.
Yeah.
In terms of the command lines, specifically, in terms of how the command line operates.
Okay.
So Unix was like the big daddy of the operating systems.
Yeah.
So if you're asking about like the very first one, well, Unix was the very first one. But the reason why Windows is prevailing compared to Linux actually has nothing to do with who was the first.
Okay.
It solely has to do with, well, Linux's biggest advantage is the fact that it's free and open source, but that's also its downfall. Because Windows, because it is proprietary, what you also have is Windows support.
Ah. Yeah, no, that makes a lot more sense.
Exactly. So you have some Linux distributions that are proprietary. You have Red Hat, for instance. Red Hat. And Red Hat, like, if you, depending on who you ask, it's like, I've had this conversation with a few colleagues, and a lot of them have told me that, Red Hat is basically a scam because they're making you pay just to use a free open source software, and it's ridiculous. And that is true, but because it is because Red Hat is a proprietary distribution, it means
also has its advantages.
exactly, it also offers some form of support. And so that's why you have like a derivative of Red Hat, which is CentOS, which this one, so it's essentially like Red Hat copied and put into an open source software. So
Okay.
CentOS is open source. It functions very similarly to Red Hat, but because it is open source, it doesn't offer that, that professional support that
Yeah.
you might need, in particular in an enterprise environment.
Okay.
Yeah. So in fact, most enterprises will care more about the support than they will care about the fact that it's free. Like, they have money. That's the point of an enterprise. And in fact, support is so much more like, imagine your server crashes.
Yeah.
Well, either you hire your own IT team and hope that they don't mess it up, because it's very easy to have people who think they know what they're doing. And that's fine when they're working on their own home lab. But when they are actually touching like production environment, you don't want them to mess up at all. And in fact, you even want that if they mess up, you want like some form of insurance. You want to make sure that if it doesn't work afterwards, that you get your money back or something. But if you hire your own IT team to do that on open source software, you don't have that insurance. If you hire
No.
if you use Windows Server or Red Hat, for instance,
Yeah.
well, as long as you pay Windows, they will make it worse. At worst, what they'll do is they will just install a brand new installation of Windows. Like, they will make it work. And if they don't, well, then you have had some form of insurance with them. You have a contract with Windows.
Okay.
Right. So that's one big reason why Windows, it's not that Windows is easier to use, right? I guess Windows today has more maturity as far as user experience goes, because it's been like the standard like the PC operating system for so many decades.
Yeah.
Now everyone's used to Windows, right? And it's
Yeah.
had a lot of time to mature. And how often do you have to go in the Windows console line?
Never.
Never, right? You don't have to if all that you do is use a web browser and install games.
Yeah.
On
But
Linux, however, you would have to.
oh,
Probably.
really?
Not necessarily, but it's more likely that you will have to.
Okay.
In fact, in the console line, so we will do a little bit of console line. Console line is not very scary. I want to make sure that this is clear. As long as you know what you're typing, it's not that scary. In fact, Linux is super powerful. One of the biggest advantages. So you can easily find sort of videos explaining the difference, like the advantages of Linux over Windows. One of my favorite is the package manager. So let's say on Windows you want to install something.
Yeah.
You have to go online, so you open up your web browser, search for a download, hope you're getting the proper download and not like some kind of, crappy stuff that's going to install like some search bars on your browser or whatever.
Yeah.
You want the original software, right? Well, and you have to find the right one, and you have to check that it's the correct one, and that's a whole mess.
Yeah.
On Linux, you open the terminal, or if you're using a user-friendly distribution, you just open up an application. And it's
Okay.
like, imagine the Microsoft Store, but
Yeah.
actually useful. Right?
What?
So it's the Microsoft Store is sort of trying to emulate what Linux Package Manager does.
Okay.
So let's see. The way a Linux distro works is that you have servers that are called repositories or repos. You have several of them.
Yeah.
Online. So let's say you are here using your computer and you're connected to the internet. Right? So you have those repos. And let's say you want to let's say I want to install Office. Okay?
Yeah.
You want to install OpenOffice. So you're going to ask one repository at a time. You're going to ask them, "Hey, do you have OpenOffice?" And they'll say, "Yeah, here's OpenOffice."
Okay.
And then it just installs it. And all that you do is type a command line. Or like a command line that would look like sudo apt get install OpenOffice. Office. You type
What
something
is
like that, and it just installs it on your computer, and that's it.
what does sudo apt mean?
We will get into that.
Okay.
We will do a little bit of Linux command line, so we'll get into like
Oh
the
yeah.
very basics of Linux
Okay.
command line. Right. So in my eyes, this is like a super big advantage because you don't as long as you trust the repositories that come in pre-installed on your distro, as long as you trust them to not install bullshit on your PC, you're fine.
And who manages these repos?
Usually, they're so you have. I know there are lots of universities that
Yeah.
actually manage them because so that I think that's really cool. You have universities that essentially want those repos at least for themselves, and then they're thinking, might as well make them public because
Oh
it's
wow.
kind of the mission to the university, for instance, to make that sort of open source knowledge, that sort of knowledge, because at the end of the day, a software is just information, it's just data, it's
Yeah.
speech. So it's part of the goal of the university to say, hey, we want to make that knowledge available to everyone, and so it would make sense that they would make it public. So a lot of universities do that. You have also a lot of just like not necessarily individuals, but groups of individuals. So whoever manages the distribution itself. So let's say you've installed Ubuntu, not Ubuntu because it's not open source anymore. Let's say you've installed Debian. Damn, I'm my handwriting, man. Let's say you've installed Debian.
Yeah.
So Debian has a team of developers working on it constantly.
Yeah.
And when you install Debian on your machine, there comes a like on the distro, there is a pre-existing list of repositories,
Okay.
right? And so usually all of those are managed by the same group of people. And usually they're doing it for free. So this is why very often on things like on distribution pages and stuff like that, you very often have a donation link.
Okay.
It's precisely because it's free, and it's free because like it means they pay it out of their own pockets very often.
Yeah. Interesting.
Yeah. So personally, the reason I use Windows even right now, like there are two reasons I'm using Windows. First is because to play games on Linux, I mean it's feasible, but like not all games, and your performance can vary. Second reason is I'm kind of lazy, and like I tried OBS on Linux and I found that for some reason my audio codecs or something were messed up and my mic just sounded like trash on Linux. So I decided, fuck that, I'm just gonna stick with my current OBS install that work on Windows that works just fine.
Yeah. Probably for the best.
Yeah, right. I mean, at least for the time being.
Yeah.
Okay. So that's a brief history of operating systems. So what's so interesting is the fact that in an enterprise environment, what we care about isn't the cost. What we care about is like the support. Paying for support is worth it, even if it's very expensive, and even if like Windows is a lot heavier than Linux.
Yeah.
Like, have you ever heard of IoT?
Mm, I don't think so.
IoT is it means Internet of Things. So it's like first there was the Internet of People, where people were connected on the internet, but now it's the Internet of Things, meaning you have so the Internet of Things would be connected objects.
Yeah.
So for instance, a self-driving car could be a connected object. Your
The
phone is kind of a connected object.
yeah,
A
Google
smart
um
homes are a connected object.
yeah.
A smartwatch is a connected object. Park meter, an electronic park meter is a connected object, and all of that. You have a bunch of stuff like that. And so
Okay.
IoT devices tend to be very small, have very little battery, like very low power, like super tiny stuff.
Yeah.
And they have like 1 megabyte of internal storage. maybe not 1 MB, but like they have
A low amount.
like 200 megabytes of internal storage. You can run Linux on it.
What?
Yeah, you can run. You have a Linux core running. Like all IoT devices are going to be running on some form of Linux. Really, all of them, because it's
Okay.
tiny, it's lightweight, it's open source, meaning it's already done. Like, why reinvent the wheel? Why
Yeah.
would you, if you're developing an IoT device, why would you go through the motions of like developing an entirely new operating system for it when you can just take the Linux core and adapt it to what you have,
Yeah. Good point.
right? And so that's why, for instance, that's why you have, like you explained, you have, first of all, Android is actually Linux based.
I heard something about like that one day.
Yeah, Android is actually Linux based.
Yeah.
So you have Linux distros that can run on. You remember what I mentioned about ARM?
Yep.
Right. So ARM is the mobile chipset.
Yep.
You have Linux distros that can run on it.
Okay.
Have you ever heard of Raspberry Pi?
Yep. I was just thinking about that a couple of minutes ago.
Exactly. Raspberry Pi is an ARM processor running a custom version of Debian that runs on ARM.
Okay.
Right. So, why do we care about operating system? Now that it's very clear what an operating system is, it's like the bare metal, it's like the lowest level of software that's going to be running bare metal on your computer. And you have plenty of them, and they depend on what hardware you're running. Okay. For desktops, we mostly have Windows, Mac OS, Linux. With
Yeah.
a couple of outliers such as FreeBSD and Solaris, we will actually be using a special version of FreeBSD
Okay.
for pfSense. pfSense is based on FreeBSD.
Okay.
Okay. So now we know what an operating system is. Now, what is virtualization? So you mentioned that you believe that virtualization was about running multiple operating systems on the same machine. Is that
Device.
correct?
Yeah.
Right. That's basically it, honestly. So you have. So why would you even care to do that? Do you have any ideas why you'd want to run multiple OS on a single
Well,
PC?
I guess one reason, which would have to be a very specific kind of term or specific requirements, was if someone was testing out a piece of code and then
Right.
somehow it just goes awire and deletes a very important file on the computer. With a virtualization machine, it wouldn't do that. It would keep your computer intact without breaking anything.
That's a good point. So I want to run a sensitive piece of code, for instance. So, like for instance,
Yeah.
ha- have you ever used Photoshop?
No.
Okay, let's assume you have.
Okay.
Do you pay for it?
Mm,
It's okay. You can say it.
no.
The
Thank
FBI is
God.
not gonna come after you.
Thank God.
So,
No.
especially since you said you never done it, but like you wouldn't pay for it. Then how do you do? Because you're not gonna pay $10,000 to use Photoshop,
Oh
right?
God, no.
Right. So what do you do?
I download a file which has already been cracked.
You
Or
download a crack. So a
yeah.
crack is essentially a version of Photoshop of which the source code has been modified a little bit.
Yeah.
That's terrifying, isn't it?
It is.
Because you
There's a
don't
lot
know
of
what you're downloading. Like there could
no,
be
you
anything,
don't.
right? And in fact, in most cracks, whether it's Photoshop or games or anything like that, you always like you can't. The assumption you have to make is that there is some form of malicious code in it.
Which is probably a malicious code to modify the source code, as you said earlier.
Actually, what I mean is that the source code has been modified and includes a malicious code in it.
Oh,
So it runs malicious code on your computer.
okay.
Right. And usually that can be a Trojan, that can be a keylogger, that can be even something as simple as a botnet. But it's basically nothing that you want to run on your PC.
Yeah.
Right. So yeah, you'd like to isolate that. You'd like to say, I want to use Photoshop for free. There's going to be a virus in it. I want to put it in like a box, just use it for my like picture editing or whatever, and then do nothing else, and like isolate only that, so that if there's something dangerous happening, it at worst it only fucks up that one isolated part of my PC.
Yeah.
Right. So let's say you're running your Windows install. Let's make it blue. You're running your bare metal Windows install, because at the end of the day, you still need a bare metal operating system.
Yeah.
You want to install that malicious piece of software because, you like to live dangerously. So what a virtualization software will do is it will mimic a second computer inside your computer. And then in that virtualized computer, it will run another operating system.
It's a bit like computerception.
It's exactly that, actually. You have a copy of Windows. Here you have a second copy of Windows. So suddenly you have two copies of Windows running on the same machine, but we have specific terms. The outside, the bare metal Windows install is what we call the host.
Yeah.
And the inside one, the virtualized one, is what we call the guest.
Okay.
So what you'd want to do then is, yes, install the sensitive software on the guest operating system.
Is it possible for a file from the guest operating system to make its way to the host operating system without you knowing about it?
It is possible. It's very specific, but it is possible. The isolation is never perfect, right? Like, okay, so if we're talking about if we need to talk about security a little bit, security is relative. In there is no perfect security. What you want to do is you want to make it as expensive and unlikely for whoever is attacking you to succeed.
Yeah.
That's the point. But you cannot have a perfect protection. But you can make it not worth it. Or really, really hard. That's the case for encryption, for instance. If you encrypt something, at worst, it's going to take very, 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 very long to decrypt it, to brute force it. But it's always feasible, right? It's like you have a big number combination, right? You have to guess, let's say, 10,000 numbers.
Yeah.
Well, it's going to take you forever to try every combination.
Yeah.
But it is possible. Maybe you can randomly find the correct one.
Yeah.
Okay. So, yeah, security is never perfect. In the case of things like keyloggers and stuff, so the better way of doing it is, first of all, in my opinion, so this is not professional advice, right? I'm not saying that this will protect you. But I am saying that a good practice would be, for instance, to run, instead of running the same operating system twice for the host and the guest, what you could decide to do instead is, let's say, run a Linux host. Hold on. A Linux host and a Windows guest. So suddenly the software, like it means that the malicious software you've installed first of all has to figure out that it's running on a Windows VM, and once it makes its way to the Linux host, it has to already be prepared to infect a Linux host. So that's very unlikely.
Yeah. Because
right. It's not impossible, but it's very unlikely. And the cost of developing a piece of malicious software like this, the cost is like,
Expensive.
yeah, it's very expensive. It's very, and especially because, so it'd be very expensive to develop, and it's so specific. Like how many people are you going to infect with a malware like that? How many people are running a Windows guest inside a Linux VM specifically?
We don't know for sure because
Not many, not that many. That's for
really,
certain. Well, of course, if like let's talk about Photoshop again. The example of a cracked Photoshop. Who installs Photoshop? Who uses Photoshop cracks?
well, those who are probably gonna use it once or twice and don't want to pay for a full service.
Well, yeah, right. Like end users like, John Smith and whatever.
Yeah.
Okay. Do you think John Smith runs a Windows VM inside a Linux host?
No, the other way around since Windows is more popular, right?
Well, do you think John Smith even knows what virtualization is?
Good point.
Exactly. In fact, most of the people that are going to be downloading that piece of malware don't even know what virtualization is. So, is it really worth it developing a piece of malware that would infect maybe like 5 people?
No.
No, it's not. So they don't care. So that's why it's better. Like I said, you want to make it economically not viable for people to try and infect you.
Yeah. All right.
It's like, I love that analogy. It's like you and your friend are walking in the woods and suddenly you run into a bear.
You just have to run faster than your friend.
Exactly. You don't have to outrun the bear. You have to outrun your friend. And you live.
Yeah, but your friend dies.
Who cares? He should have been faster than the bear. No, but seriously, that's how it works. You just make it so that it's better. Like you want to make yourself as unattractive as possible.
Yeah.
And end users like you and me, as long as we put like simple defenses into place, there is like barely anything that a hacker could possibly get out of us. Like for instance, if a professional group of hackers really want to infect your network, they will. They won't have any issue doing that. But it'll take them a lot of resources, and what are they going to get out of it? At best, they're going to ask for ransom, like they're going to sell all your data and ask you for a ransom to like get your data back. Like they're going to lock your data and ask you to pay like $10,000. Do you think it's not worth the $10,000 for them to like go to these lengths? As long as you have a simple firewall in place, that's enough for them. That's enough like to deter them. That's enough to say, hey, it's going to be really expensive for you to get barely anything.
Yeah.
So yeah, that would be a good act. Like this is a good example of when I personally like to use VMs. Is precisely like, hey, I want to install a piece of software. I'm not sure I can trust it.
Okay.
Another case would be still in the idea, still like for end consumers like you and me. Let's say you want to. There's a freemium software you'd like to use. Let's see, for instance, what's a good example? So you want to try a free trial. Let's keep free trial for Photoshop. There, I don't know if there's a free trial for Photoshop, but let's say there is.
7-day free trial for Photoshop.
Right, 7-day free trial.
Isn't not worth it.
Well, hold on. So you want your 7-day free trial?
Yeah.
You don't want to install the crack.
No.
Okay. But obviously, you're gonna have a problem. First of all, the trial is linked to your account.
Yeah.
Okay, you can just you create a throwaway email. You have services dedicated to doing that, free services. So you create a throwaway email. You create a new account. Takes you 2 minutes. And if you use Photoshop for like if you use Photoshop for your personal YouTube channel or something, maybe it's worth it. You spend 10 minutes every day, like every week, renewing your free trial. Maybe that's fine.
Yeah.
Okay. But then you run into an issue is that Photoshop is not stupid. They're like, no, you can't install a Photoshop free trial on the same machine twice. You can't do that.
Hardware.
Right. So what they will do is they will actually check some serial numbers, some MAC addresses, and we're not going to go too much into detail as to what this means, but essentially they're going to track what piece of hardware the Photoshop trial has been run on.
And then if the same pieces of hardware reappear in
It
his
just says
sequence,
no, you've already used it. Like you can't.
yeah.
Right.
One of my friends got hardware banned on Apex.
On what?
That's Apex Legends.
Oh, really?
Yeah, because he was supposedly aimbotting even though he just lucked out.
Well, that's unlucky.
And so he had to, I forgot which service it was, but he had to download something to change the serial number of like his graphics card or something, and then make a new throwaway account for Apex.
So most likely it was to change the serial number of his motherboard.
I think so.
Yeah, that's usually how it works to track. So for instance, that's also how it works in Windows.
Okay.
Windows will track what activation key has been used on what motherboard.
Okay.
But then, okay, so you need to change your serial number, your motherboard serial number pretty much every single time, right? Like every week. But obviously, like if you were to do that on your bare metal install, you'd have to buy a new motherboard every week and rebuild your computer from scratch.
No thanks.
Yeah, let's not do that. Or you can spend $10,000. Yeah, let's not do that.
No, bank account
No.
isn't big enough.
Exactly. So you can just go for the crack, or if you want to make sure that there is no like security breach, what you can say is, well, since I'm virtualizing, like so what I do is I run a Windows VM, right? I install Photoshop on it. But every time, what I'm going to do is every single week, so I will copy this, right? I will copy this. I will do what's called a snapshot.
Okay.
So think of a snapshot as like you're taking a picture of everything going on in a computer at one given time. So you're taking a picture of the RAM, of the memory. You're taking a picture of the hard drive, of like all the components, all the devices, everything running on the PC right now. You just take a snapshot. You just take a picture of it and you save it. And you save that picture. And then what you can do is you can tell the virtualization software, you can tell it, hey, here's a snapshot. Please generate a VM from it. Like it's like you're copying the VM. And you can't really do that. Like it's much more versatile than, let's say you want to back up your bare metal Windows install.
Yeah.
You have to use a specific tool that will do that. And if the tool, like that tool will take some time to run, if your PC for some reason shuts down during the process, like you lose everything, it's very scary, right? It's not very flexible. A snapshot is not instantaneous, but there is there is no risk that I know of, at least, of like breaking your machine, neither your guest nor your host. So it's much more versatile.
Yeah.
Right. And so what you can do is you take a snapshot, and then you're going to copy it later in a new, so you delete that machine, and then you put it in a new machine and you change the serial number.
Okay.
So Windows might, not be too happy about that for a moment. That's fine. You let Windows do its thing until it's properly working again. And then Photoshop is like, oh, hey, that's a new serial number. Let's install the free trial.
Because it isn't the same thing.
Exactly. Now, obviously, there is not an infinite amount of serial numbers. For something I don't know to what frequency you will, like, I don't know to what frequency you're going to run into used free serial numbers for something as popular as Photoshop.
Yeah.
So it's actually kind of funny. But there are lots of serial numbers still, and that would be a viable strategy. There is some overhead to doing this, obviously. Like you're spending, I don't know, maybe it would take you maybe 15, 20 minutes every single week to do all this. But again, that might be worth it.
Yeah.
Obviously, this is not worth it in an enterprise setting.
No.
No, because in an enterprise setting, you need people working like actually all the time. And in an enterprise setting, you will pay the $10,000.
Because, well, it's an enterprise. You have the money.
You have the money, and that way you also have the Photoshop support, like the Adobe support. Right?
Yeah.
it's not like again, an enterprise will like money is less important to an enterprise, to a company, than service, than support,
Okay.
right? So that's why you have so many features, like even from manufacturers, like you have I remember weird stuff coming from Intel that would let you I don't remember how it's called, but that would let you, it's some form of remote access to your hardware, and that
Oh
thing is like
no.
super expensive and not working too well. But in an and you have like free alternatives to that. But in an enterprise setting, you'll just go with the Intel thing, even though it's literally worse, and even though it costs money instead of not costing money, simply because if something doesn't work, you call and you just phone Intel and it works.
Yeah.
Exactly. Okay. So this is like the second case for like consumers for why they want to do virtualization. Uh, and the third example is what we are actually going to do. Well, if we have the time today, I didn't think we'd be taking so long, but this is fine. Like this is fine. We can do it maybe in two time, like in two sessions.
Yeah, it's better to understand everything in one moment instead of having
Yeah,
to repeat
I'm thinking we might actually do that. Up to you also. So
Yeah.
remember what we want to do. Let's see if I can zoom out. Okay, so we said later on, like for the VPN lab, so to test out VPNs, we're gonna have to run multiple operating systems, right? We want to run a Linux machine and a pfSense machine and a Windows machine all at the same time. Do you have 3 computers laying around that you can install 3 different like one operating system on each of them?
Hell no.
No, you don't, right?
Nah. Nah, nah, nah,
You definitely do not. How like yeah, no, you don't, right? It's
no.
very expensive to do that. So
I have
instead, what we're
computers
gonna
lying around, but they're not parents. I'm pretty sure they would kill me if I changed anything.
right, and also exactly right. So you'd have to like do permanent modifications to your computer's hard drives and possibly mess up like the already pre-existing Windows installs and stuff.
Yeah, no, I'll
So
pass.
just as a side note to that, there is actually a thing called dual boot, where you have one computer and 2 different operating systems installed on it. So for instance, Linux and Windows. And what you do is at boot, you decide which of the two you want to run. At boot.
Okay.
So you only run one at a time, but you can decide which one.
Yeah.
I'm personally not a big fan of dual booting. Like it was very prevalent before virtualization was really like so democratized. Today I wouldn't recommend it because why dual boot when you can just run a VM,
Fair point. And
right?
I'm guessing it might be a lot simpler to just run a VM either way.
Well, technically you have better performance on dual boot.
Oh.
But if what you're doing is run like so, okay, if you need 2 operating systems and you actually need both of them to be very performant to use all the performance of your machine, then
Yeah.
sure, you have to dual boot. But this is very rarely the case. Usually you have like one main operating system for which you want high performance. So in our case, that would be Windows, right? You want that to be your main OS because you want to run
Yeah.
games on it. Like just that, you're gonna need high performance. And
Okay.
then maybe you want your secondary operating system to be Linux. Just because, you want to learn Linux, you want to try things out on it. But it doesn't matter if it doesn't have high performance,
Yeah.
right? Like what we're gonna do is just labbing. Just to lab, we don't need high performance. We need like one CPU core, and that's it.
Yeah.
So if you want to install 2 operating systems, you can do that. So dual booting is like when you have two operating systems on one hard drive.
Okay.
You have yet something else, which is not dual booting, but it kind of feels like that, is you have 2 operating systems on 2 hard drives, right? So you have your Linux install on maybe like an HDD on
Yeah.
a physical hard drive, and then you have a Windows install on your SSD, let's say.
Yeah.
It's not dual booting, but it still sort of has. So this second, so this method with 2 hard drives is not bad you do get high performance, and because the two operating systems are installed on two separate hard drives, you have better isolation.
Yeah.
Right, they're better isolated, so you have less risk of like Linux messing with Windows or Windows messing with Linux. I've had that happen to me before, where I was running dual boot, so two operating systems on the same hard drive,
Yeah.
and then I got rid of one of them because I felt like I was never using it,
Yeah.
and then that actually messed up some things for my Windows install for the other
wow.
operating system. Thankfully, I was able to recover everything, but like it was a matter of partition management. But it's not trivial. It's really not trivial. You don't want to, like, you want to avoid dual booting. In my opinion, it's not a viable thing to do in 2020.
Okay.
But just know that you can do it, and that, for instance, let's say you want to. So when you install, for instance, Linux, when you install it, it often asks you, "Hey, do you want to, like, we've detected an installation of Windows on your computer. Do you want to wipe the installation, or do you want to install it alongside Windows?"
Okay.
Right? And if you want to install it alongside Windows, that means you have the option of dual boot, meaning installing the two of them on the same hard drive.
Yeah.
Right? If you have two hard drives, you still want to install them like alongside each other, but it'll give you the option to install them on separate hard drives.
Okay.
So what we will be doing is we will be running one Linux host, one Windows host, and one pfSense host. So we're going to be running 3 operating systems. I think that's really cool. Right?
It is.
You're running multiple operating systems on the same machine. And it's so fun because now you're treating operating systems like they're just software. Right? Like Windows is just a piece of software now. Linux is just a piece of software.
Okay.
Right? I mean, yeah, we're installing Linux, we're running Linux, uninstalling it, modifying it, copying it. It's essentially a software, right? Just like, I don't know, Valorant or any game, or just like Photoshop. Like, you're treating it like it's just a software.
Yeah.
Obviously, virtualization has its downfalls, though. So, one issue of virtualization is that each operating. So I'm gonna. So first, before we move on, how's it going so far? Are you feeling a bit tired? Do you want to take a break?
No, I'm good.
Okay. So let's say I'm going to represent the performance of your machine. So let's say that this right here is the total performance of your hardware. This is your hardware performance.
Yeah.
Okay, so green is hardware performance. And then blue is going to be your host operating system. So Windows is always going to have some overhead, right? Just to run Windows, you need a little bit of RAM, needs a little bit of CPU just to run, right?
Mm-hmm.
So you have some what we call overhead. You have some overhead just to run it, even if you're not doing anything.
Yeah.
Okay. And then we said, okay, in our example, well, we want to run another Windows machine, right? Again, we're talking about the total performance of your machine here. So we want to run another Windows machine. And we want to run pfSense, which doesn't take quite as much, but still takes a little bit. And we want to run, let's see. Okay, let's use, and we want to run Linux as well. So we're running 3 operating systems. And even without doing anything on any of those operating systems, we're actually running 4 of them, right? We're running 1 guest and 3 hosts.
Yeah.
Even if we're not doing anything, it actually still takes sort of quite a bit of performance, right? We have all that overhead.
Yeah.
So this is the problem with virtualization, is that it has quite a bit of overhead. Especially, so Linux obviously is quite lightweight. Something like pfSense isn't very lightweight. I mean, FreeBSD is, but then pfSense, the firewalling operating system, isn't. It's not super lightweight.
Okay.
But Windows is like particularly heavy.
Yeah.
So this is what happens when you just do basic virtualization, so basic VMs, virtual machines. You're running the entire operating systems multiple times.
Okay.
One really cool thing that you can do in Linux, though, is like the next step in the evolution of virtualization, where you have your Linux machine. So first of all, let's say you're running a big Linux machine, right? So big overhead like Windows. Usually it would be much smaller, but let's say worst case scenario. Well, what you can do is you use a technology. So if what you want to do is run other Linux VMs, so you always have that Linux core, right? You have that somewhere in here. You have the Linux core that's running, right?
Yeah.
What you want to do is run multiple instances of Linux. Maybe there are different distributions, sure, but like you want to run multiple instances of the same Linux core, right?
Yeah.
So why bother creating the same overhead multiple times when what you can do is just have very little overhead, like very, very little overhead, and just ask them to refer to the Linux core. And suddenly, each box, we're going to give them the specific name afterwards, each little box here, each operating system that you run is still isolated from each other, but is going to refer to resources that already exist on the host.
Okay.
Right. And so we call this. Do you have an idea what we call this? Maybe you've heard of it before.
I don't think so.
Okay, we call these containers.
Yeah, no, haven't heard of it before.
And so containers. So the only problem is that containers only run on Linux, in the sense that it doesn't. So the most famous container software is Docker, or container framework, I guess you could say, is Docker. You also have, let's see, very low level container technology. So what's so funny is I actually have, I'll put that in the description and I'll send it to you as well. There's a really good video that explains how containers work, and it's fantastic, and it has to do with namespaces in Linux. I guess it's a bit more specific to Linux and how Linux works and stuff, but it's super interesting if you want to have a look at it. It's super interesting. But like, so Docker is a framework. You can use it with, so other softwares that use Docker would be, for instance, Kubernetes that use Docker. Docker is, I believe it is open source, but it is at least free to use.
Okay.
So you can install Docker. And then you have like much lower level container technology would be LXC. So for instance, if you really want to like delve deep into how containers work, you would be using LXC.
Okay.
The equivalent for VMs, so we have right now VMware. So that's what we're going to be using. VMware Workstation is what we're going to be using to run VMs. Low level. So when I say low level, I mean close to the machine.
Okay.
Okay, yeah, I said LXC is low level, and I assumed you knew what it meant. But yeah, low level means very close to the machine. It doesn't mean simple. In fact, it means quite the contrary, because there is very little abstraction, right? We're not simplifying things. We're very close to the machine.
Okay.
And so very low level virtualization software would be KVM, for instance. KVM, which is open source and free, but I believe, I'm actually not sure. No, and you know what? I'm not going to say anything. I'm not sure if VMware uses KVM. I know another so the virtualization software, we call that a hypervisor.
Okay.
Hypervisor. And so, hold on, I'll just make a quick search because I can never remember which one is type 1 and which one is type 2. Hypervisor type 1 and 2. Okay, yeah. So you have, on the one hand, you have type 1 hypervisors, which is what we're going to be using, which we call also like hosted hypervisor. So type 1 is you have a Windows install and you're running the VMware software on that Windows install.
Okay.
And type 2, and this is where it gets really cool. Type 2 hypervisor means you're not even running Windows. Like what you're running bare metal is the hypervisor.
Oh.
So it's a special operating system, right? So let's draw the performance of your machine again. It's a special hypervisor that has usually extremely low overhead, extremely little overhead, right?
Yeah.
And that hypervisor, like that operating system, is your hypervisor. This thing here is the hypervisor.
Okay.
So usually in a software, like if you want a server, a virtualization server, you will run a type 2 hypervisor. And one of the type 2 hypervisors, there is one from VMware, which is VMware ESXi. VMware ESXi. But you need a license to use it. And also, I've tried installing ESXi on my personal server. It's not simple. You need to install drivers for the NIC and stuff. It's not simple.
Oh.
Personally, like what I like to use is an open source type 2 hypervisor called Proxmox. It is Linux based.
Yeah.
And it runs, so it's going to run VMs using KVM. So that is the very low level software that runs VM. So it's going to be using KVM to run VMs. And it can also run containers using LXC.
Okay.
Right. It also has a bunch of other features and stuff, but so far this is enough. So if you want to run a server, so okay, what's the advantage? Now let's talk about the enterprise, the advantage in an enterprise environment. What advantage does virtualization have in an enterprise environment? Because obviously, in an enterprise environment, like we don't care about Photoshop free trials and stuff like that, right?
Right.
Right. So what do we actually care about?
Well, I guess isolation.
Isolation. Okay, but why not just run multiple machines? Like
Be
I can have multiple servers and they're isolated from each other, right?
because with server it would be only one connection instead of having multiple PCs with multiple connections.
I'm not sure I understand.
Like with a server, isn't it basically just this giant computer which is connected to other smaller computers?
Uh a server is basically a computer. Like there is
Yeah.
no qualitative difference between your computer that you're using right now to call me on Discord and a server. The only difference is in like what kind of application are you running on it.
Okay.
So server can either refer to the machine or it can refer to an application. So for instance, I could say when I say HTTP server or web server, I either mean the application. So let's see, what could be, for instance, NGINX or Jenkins. Let's say NGINX. I'm not sure about Jenkins. So the HTTP server can be the application running on a machine, or it can be the machine that runs the application.
Okay.
The machine that runs the application.
Yeah.
What I'm talking about here is more like the physical part, right? So the machine. So when I talk about servers, I'm talking about a machine that will be running 24/7, most likely, and will be running a service. For instance, a web service.
Okay.
So, do you have any idea? You had a really good idea with isolation. I'd like you to sort of follow that thought.
Well, if a server is running multiple virtual machines, I guess the virtual machines could be somehow dedicated to either a not I don't want to say a client, but a user's personal computer at their office or at home.
Oh, that's interesting. So, hold on. So you're talking like in the event that okay, let me see if I understand. So I have my server, and what I want to use this server so that so I want to run like let's say multiple Windows hosts on that server.
Yeah.
Right? And I want multiple remote users through the internet, for instance, and maybe through a VPN tunnel. Wink, wink. So let's see. That server would be physically connected to the internet. And then we reach a client somewhere. And so you're saying you'd like maybe the client needs their own sort of professional desktop, even though they're not at their desk. Is that what you're talking about?
Yeah. Like if, for example, during the coronavirus or during the whole
Mm-hmm.
epidemic,
Yeah,
since I don't know if I can say that on Twitch,
it's fine.
well,
I don't care.
that could have been useful. Like if someone has a computer at home, but all of their business files are stored at their office computer, if they can somehow
Mm-hmm.
remotely connect to the server and then to their computer at the office to retrieve these files, they would be
Yeah.
able to do their work a lot more efficiently than if they didn't have the files and would have to restart all over from scratch.
Mm-hmm. That's a good example. Yeah. So Um, so I wanted to use the example of lockdown and all of that and remote working to explain why VPN technology is important for enterprises. So we'll do that later. Also, it'll come back.
Okay.
But yeah, this is a decent example. So let's say you have for some reason you want users to have like you want to store multiple desktop environments that users can remotely access.
Yeah.
Well, then yeah, you'd absolutely have to run virtualization for that.
Yeah.
Like there's because the alternative would be to like literally let hundreds of personal computers running at all times and like configure them so that their specific user can like be specifically routed to it. Like it's a whole mess. We don't want to do
Yeah.
that.
That sounds
Right?
complicated and very
Yeah.
expensive for the
and,
end user.
and and also you're talking about so you'd be wearing out a lot of component, like you'd be wearing out hundreds of computers
That
instead of
too.
just one, right?
So in the end,
And
it's going to be very expensive.
it is like it's going to be physically very expensive. Yes, it's
Yeah.
not trivial at all.
I didn't even think about that.
And that's actually so the that physical component is actually the reason why we do virtualization. And virtualization goes way beyond just desktop environments.
How
There
far can
is
it go?
well in an enterprise environment, usually you want to instantiate some policy that one app equals, so for servers specifically, so one app would be, for instance, one HTTP server.
Yeah.
One app means one OS.
Okay.
You want to do that so that you can then tailor the operating system to perfectly serve the app. Because the problem is if you have multiple apps running on the same operating systems, well, you're never certain how these different apps are going to interact with each other.
Yeah.
So you want to isolate them as much as you can. So
Sort of
you want to run them on different operating systems.
sort of like the dual boot, how Linux and Windows can interact with each other.
They
You
don't.
don't.
They don't
Oh,
actually connect back. So in the case of dual boot, you would only be running one operating system at a time.
yeah, but I mean like how you deleted Linux and then it somehow affected the window.
Right, something like that. Except
Yeah.
like I'm talking about apps as in applications you can install on an operating system, not the operating systems themselves. It's a little bit different, but that's kind of the general idea. Is you want isolation.
Okay.
So Like you've probably had it on your own computer that, a piece of software you've recently installed somehow changes the way another piece of software behaves.
That is annoying.
Right, it is. Well, then it would be a lot simpler if you had like one app for one operating system. You would never have that issue. Well, I can't say never because isolation is never perfect, but
It
basically
would,
never.
yeah, would limit
Right.
the
Right.
interactions.
Right. But then without virtualization, we run into the issue that we need one physical server per app. Right? So for instance, and this is why, so for instance, we'd have the HTTP server and we'd have one app running on it. And then we'd have another server dedicated for FTP, for instance, with one app running on it, and so on and so forth. The problem with that is, well, maybe your HTTP server isn't running at full power all the time. Maybe it's running at like 10% when idle, 10% CPU utilization. And
Yeah.
maybe the FTP server is running at 20% CPU utilization. And
Well,
maybe you have another server, like, let's see, you have a Minecraft server, obviously very important in enterprise.
yes, the only thing that matters.
You have a Minecraft server, and this one is maybe running at 50% CPU utilization.
Won't that be very expensive for the components?
Yes, actually, yes, that's the whole point. This is so phenomenally expensive. You have to keep 3 machines running at like all the time, 24/7, and you're
If
not even using like
outages.
you're not even using half of their power. Usually, you want to sit around 70% CPU utilization. That's a good spot to be in. You're using a lot of your compute power, but you still have enough you still have enough margin that if there's a burst of activity, you can manage it.
Okay.
So if you have one machine, one physical machine per service, per application, like you're going to run into that issue of like CPU utilization. And I'm just mentioning CPU utilization, but obviously you also have RAM's utilization. You have
Well, the hard drive makes the
networking as well.
yeah.
Like you have all of these components that like you're probably barely using half of them at best. So you've paid for something that's not worth it. The last thing your boss wants to hear is that he paid for something that isn't being used.
I'm guessing that's the boss's worst nightmare.
Well, yeah, kind of. Imagine you're paying for something and then you ask, okay, how is it doing? And you say, oh, we're using 10% of it. Then why did I pay so much for it?
It would
Right?
be the same thing as just like getting, I don't know, a gold brick, then placing it in the center of a museum just to look at it.
Yeah, pretty much. Right? Like it's such a waste. And I always use this example also for something else that's called. So this is a bit beyond the class, completely outside of the class actually. But like in networking, there's a protocol called spanning tree, and I love it because it's so bad because it makes it so essentially when you have switches, when you interconnect switches with multiple Ethernet links together, just because if one Ethernet link falls, the other one can take over. You have to prevent loops, and there's a whole process called spanning tree, which makes it so that effectively one of the links just doesn't do anything, doesn't forward any traffic. And so your boss is like, wait, so you're telling me I paid for this cable and it's not forwarding anything? Yes, but it's there just in case. Well, what do you mean? No, you make it do some work.
I
It's
would
like
be
it's like you have 2 trucks. It's like you buy 2 trucks for deliveries, and you only use one of them, and you say, "Oh, the other one is there just in case." Like,
you
no,
see,
you
that
use
would
both of
be
them.
me. I would be the boss who would say, okay, it's fine. If it's just in case, I'm fine with it. Let me just buy another 5.
Exactly, right? It's ridiculous. So you want you in an enterprise environment, you always have to think of the technology in relation to like its the economics of the technology you're using.
Yeah.
So back to our example with our Minecraft server, what virtualization allows us to do is to say, okay, I'm going to essentially merge all of these services into one physical server. So I only have one physical server, and then I have 3 operating systems running on it. So I have the FTP, maybe this is a Linux server running the FTP app, and maybe this is the a Windows server running, Windows operating system running the HTTP app, and then we have like another Linux running Minecraft.
The most important.
Yeah, absolutely crucial, man. You cannot have a sustainable model without a Minecraft server.
It just kills the environment.
Yeah.
You see that the Minecraft server shut down last night. Everyone's just gonna start crying.
How can we work without dude, that should be one of the perks. Like you sign up for a company and it's like you're trying to attract very competent people and you say, well, we have snacks and we have a dedicated Minecraft server. It's like, sign me in.
Yeah, pretty much. I mean, I would, at the moment they start talking about Minecraft, I would already be signing the paper saying, okay, when's my vacation?
Exactly. So the advantage is that suddenly you have only one server and it's running at 80% CPU utilization. So it's a bit high, it's a bit on the high side. You'd want to consider changing the CPU to something a bit more powerful. But hey, we paid for one server and we're fucking using it.
Yeah,
And it's a lot easier to manage because there's one physical machine, not 3.
yeah,
So it generates a lot less heat as well, meaning I'm gonna need a lot less ventilation in my data center.
yeah.
Like, that's not trivial.
I'm pretty sure the boss would be happy.
Yes, exactly. He's very happy. And so then it's up to the IT team to make sure that you're sort of simulating a network inside of it, because obviously these 3. So essentially, it's from a physical perspective, you have only one server.
Mm-hmm.
But from a logical perspective, so once you're inside the network, it actually really looks like you have 3 servers, right? Because you have 3 operating systems. So 3 servers, each of them has a virtual CPU, a virtual set of RAM chips. They have a virtual Ethernet card, like a virtual network card as well. So you then have to decide, okay, like, for instance, so I'm more proficient in networking, and I can tell you that one big challenge for virtualization is actually deciding, how are we going to interconnect all of these things, knowing that all of this is just virtual. Like, we have to virtually manage all of the appliances. But it is feasible and it's really cool.
It seems pretty cool.
Yeah. So yeah, this is the main reason why in an enterprise environment for servers, you'd be using virtualization to save costs. Honestly, that's the main one.
Okay.
Another thing, and this is more geared towards developers. Developers, they really like virtualization and they love containers. They love using Docker all the time. Why? Well, because let's say you're working on an app, right? So you're working on, what could you be working on? A revolutionary Minecraft server, right? So you're rewriting the code for a Minecraft server.
Yeah.
Let's say. And so you're developing it, you're working on it. And you know the specs, the exact specifications of the operating system so let's say you have your desktop. This is what you as a developer, you work on your laptop, right? Maybe it's a powerful laptop or a desktop, who cares? But like, this is your workstation.
Yeah.
And eventually you'll have what we call production environment. So production environment means the final, server.
Okay.
So this is production, and this is development. Well, if let's say that you're both running Linux, right? Well, here's the problem. You clearly, obviously, don't have the exact same operating system in your development environment and in your production environment, right?
Mm-hmm.
Because in your development environment, like, you have a bunch of development tools. You have maybe like a web browser that isn't present on the production environment. You might have some
Yeah.
personal files. You don't have the same, and also you don't have the same Ethernet card. You don't have the same amount of RAM or CPU. Like, it's just a completely different environment, even if it's the same core, even if
Yeah.
it's the same base operating system. So again, you have that issue that you don't know how things are going to interact with each other. So if you start developing your application directly on your development environment, maybe the app works on your dev environment, but maybe once you port it to production, it doesn't work. And then you have to figure out, okay, what is it that's running on my development environment that makes it work, but isn't present on the production environment, and make it not work.
Oh God.
Yeah, right. Have fun troubleshooting that.
No thanks.
Right. So what you can do instead is on your development environment. So this is your Linux OS. What you say is, okay, fine, whatever. I'll just run a copy of the production environment. Right? I just run a copy of it.
Yeah.
And I develop directly on that. This is where I'm going to be testing my app. And that way, so it can't be a perfect copy, but it's much more similar to what you have in production, right? And so then you can simply port this, make a snapshot, right? You make a snapshot of this and you send it to the virtualization server. And the virtualization server is like, okay, let me take this snapshot and I'll run it.
Okay.
Right? And so suddenly, it doesn't matter where, like what your environment is to developing something. What matters is, like, you're going to create an isolated environment in which you're going to develop, and that isolated environment should be the exact same as the production environment.
Okay.
So this is really if you're going to be doing sort of development. And from what I know, the tool that's most used for that is actually Docker.
Okay.
Docker with containers.
Yeah.
Now, just as a side note, Docker for Windows is just a virtualization software. Because like I explained, so Docker, you can run it on Windows, Linux, and Mac OS. But remember what I said? Containers normally, containers only really make sense on Linux, right?
Yeah.
Because you're going to be copying essentially pieces of the Linux core. You're going to, or you're going to be copying pieces of your Linux host to the containers.
Yeah.
But if what you're doing is running Windows and running Linux on that and running, so let's say what you're doing instead is you're running Docker on Windows. So.
Sorry, I have to go again. My dad just called.
Okay. A quick intermission, guys. So, can you sort of give us a quick rundown of what we've been over so far?
We have been over the use of an OS, which in the end it is just a program.
Yeah.
And that there are many different OSs that can be used, and they have a certain CPU archetype that they follow. So a computer OS is generally a x86, and then a mobile
It's not times.
OS,
So sorry, but it's not a times 86. It's actually x86.
x86. Okay.
Yes.
So computer OS is generally x86, and then a mobile OS is generally ARM.
So it's not the operating system that is x86. It's the processor.
Yeah, the processor, sorry, is x86 or ARM.
Yep.
And then we also talked about which OS is the most popular, and that is Windows. Even though Linux is free and it is about as easy to use as Windows, it is because Windows has a support that it is the most
Correct.
used.
Yes. That's one of the reasons.
Yeah, one of the reasons. Then we also talked about virtual machine hardwares and what they can be used for.
right? So a
So
few use cases. So can you go over like what virtualization actually means?
it's sort of like a duplicate of an OS on an already pre-installed OS. So like a Windows OS on a Windows OS or a Linux OS on a Windows OS.
Can
And
you
it,
do a Windows OS on a Linux OS?
yes, you can.
Right.
And
Eh,
it is generally used for, well, it can be used for isolation.
Right. Yes. Big word is isolation. Yes.
So it just isolates a program. Like we were talking about Photoshop. If someone wanted to use a cracked version of Photoshop, but instead of infecting the PC with a malicious virus, they could use a virtual machine to run this Photoshop cracked version of Photoshop, which then it would stay on the virtual machine unless there was some very complicated code that let it bypass the virtual machine. But at that point, it would have to know that if it was whether Windows OS or a Linux OS afterwards.
Right. So you're sort of starting to leak a bit with security.
Yeah,
Like, is there communication possible between the host and the virtual machine? Yes, but it's somewhat specific and a very generic attack vector, like a piece of malware in a cracked version of Photoshop, is unlikely to include a piece of malware that's going to be able to traverse a virtual machine. Very
yeah.
unlikely.
And so we also talked about how it could be used for development.
Yeah. So this is like the use case for sort of consumers. Do you remember a few other use cases for consumers?
Hold on, give me a minute to think. No, actually, all I remember was the Photoshop example.
So there is the Photoshop when you want to avoid there's the Photoshop crack. There's also the free trial,
Oh yeah, free trial with the hardware change.
right? Because because you are virtualizing your hardware. So I'm careful with the words I'm using here. You're not
Yeah,
emulating, you're not simulating.
go
You are
virtual.
virtualizing your software,
What's
your
the difference
hardware.
between emulation, simulation, and then virtualization?
So emulate, when you emulate something, it means, okay. So for instance, we talk about emulation when we talk about, for instance, consoles. So right, for
Yeah,
instance, we would emulate a GameCube.
yeah,
Emulation happens when you don't have the same architecture between the host and the guest. So
yeah,
for instance, if you want to run, let's say you want to run an Android virtual machine, which
yeah,
is possible, you would either need the same ARM processor that you would run an actual Android machine on, unlikely,
yeah,
or if you're running x86, so like a desktop computer, you'd be running an emulator. You would be emulating an Android machine.
yeah,
So that is emulation. It can be used also. You can emulate Raspberry Pis, for instance. That can be, in my estimation, that's actually pretty good if what you're doing is if you're working on developing a software that is supposed to run Raspberry Pi. It can be really nice to actually use a Raspberry Pi emulator so that you don't have to, like, again, we talked about how in development you have your production environment and your development environment,
yeah.
right? And you don't, like, you want them to be similar but they can't be physically the same, and so
No.
emulation can help you with that. So
Okay.
emulation would be in the case where the architectures of the host and the guest aren't the same.
Okay.
Simulation is like an empty shell. So a good example of simulation is Cisco Packet Tracer. So Cisco Packet Tracer is a software that simulates Cisco network appliances. So
Okay.
routers, switches, DHCP servers, bunch of stuff like that, and terminal computer, like computers, PCs as well. But it is
Okay.
simulation. What that means is that even though like you're running something that looks like a Cisco iOS, that's the name of this Cisco operating system. It has nothing to do with Apple. But even though you're running a Cisco operating system, it looks like a Cisco operating system. It has the same command lines and everything. It is a simulation, meaning you're not actually running any operating system at all. It is a simulation. It's an empty shell. It looks like the real thing, but it isn't.
Okay.
So virtualization is like
The full
simulation is the least powerful, but also the one with the least overhead. And emulation would be the one with the most overhead, because you have to like convert your own architecture into the guest architecture, which is why emulators are like much slower than the original, let's say, console. For instance, if you're using a GameCube emulator, like if you have a computer with the same GameCube hardware, but like a similar GameCube, like similar compute power as a GameCube, but on a different architecture than the GameCube, you're not going to be able to run GameCube emulators. It's not possible. Okay. So yeah, we said Photoshop free trials, and what's the final example I gave for consumers?
free trial Photoshop.
There's also the case where for some reason we want to run multiple operating systems.
Oh yeah.
Right, like what we're actually going to be doing when we get to virtualization, where we want to run multiple like different we want to run one Linux and a Windows machine and a pfSense machine, and those are just different operating systems, and we don't have multiple computers lying around.
Yeah.
Right.
So after virtualization machines, we talked a little bit about dual boot.
Yeah, we mentioned dual boot real quick. Can you go over what that is?
Well, dual boot is when there's two OSs on the same hard drive, where you'll get a lot of performance out of what you get to choose which OS you want to use. So if you
Yes.
have Linux and Windows on the same hard drive, you could choose whether you wanted Windows or Linux.
Right.
And so afterwards, whichever one you choose will be the most powerful. No,
Not quite.
not the most
The
powerful.
point is that you can only use one at a time.
Yeah.
But whichever you pick at boot, right? You decide at boot, whichever you pick gets the full performance of the machine.
Yeah.
I was comparing it to virtualization, where when you virtualize, let's say you want Windows to be your main operating system and Linux to be your off operating system, so like your secondary.
Yeah.
If you were to virtualize, if you were to say fuck that, I'm not doing dual boot because it's too much overhead, not enough isolation, it's too dangerous. It's like, because essentially the two operating systems can sort of mess with each other. You want to avoid that. You want more isolation. Virtual machines can offer that. So what you want to do is you'd say, okay, Windows is my main operating system, so that's going to be the host. And on the Windows host, I'm going to run a virtual machine. And in that virtual machine, I'm going to run Linux.
Yeah.
Right? I'm going to run a Linux virtual machine. So your Linux machine has less performance, right? Than if it was installed bare metal. But you have the flexibility of not, like, you have much better isolation, better flexibility.
Yeah.
Right. And then I also mentioned, that you can have two separate hard drives with each their own operating system. In which case it wouldn't technically be dual boot. It's just you have your BIOS options, and you can decide, like, you just have to select boot devices.
Yeah.
So it's like, okay, like for instance, you say boot device number 1 is the Linux drive and boot device number 2 is Windows drive. So first it'll try and boot on Linux, and then it'll try to boot on Windows if it doesn't find Linux. Okay.
So after dual boot, we started to talk about the performance of the hard drive with the virtual machine, so the headspace.
The overhead.
Yeah, the overhead, sorry.
Right. Yeah. So it's not so much about the hard drive. We were talking about this, and the overhead I was talking about doesn't really have much to do with hard drive, though it also has to do with hard drive. But what we're concerned about isn't so much storage space as it is performance. So things
Yeah.
like CPU power and RAM in particular.
Yeah.
So
And
can you explain that?
well, with a Windows virtual machine,
Mhm.
the each Windows, I guess, OS on the computer
Yeah, that's correct.
has its own overspace. So
Overhead
overhead. So basically, you'll have two windows with consuming the same amount of power.
of processing power, RAM,
Processing
storage, and all
power.
that. Yeah.
And then with Linux, it uses your main OS, so the host, and then it uses the core of that host.
So okay, hold on. That's not exactly correct. So first, to stay on the topic of VMs, when you just run a VM, a virtual machine,
Yeah.
you are running an entire new host. It's like you're virtualizing. So when you do virtualization, each of these OS here, so when two Windows OS, two Linux OSs, each of them you're going to virtualize like a computer. So you're going to be virtualizing a CPU, you're going to be virtualizing a motherboard, a network interface, hard drive, RAM, and all of that. Like it's the whole deal. You're going to virtualize the entire thing. And in this case, you're going to be virtualizing it times 4 because we're running 4 operate. I mean, here we have 4 guests. In this example, we have 4 guests and 1 host. So we will run that hardware virtualization 4 times.
Okay.
A different technology that uses a lot less overhead is containers. So instead of running 4 virtual machines, complete virtual machines, you're just running 4 very small pieces that don't require as much overhead. And what they'll do is whenever they need like a piece of hardware or like some access to like some function of the Linux core or something like this, like of the core of the operating system, instead of running it an extra time for each VM and creating more overhead, we're just going to refer back to the host.
Yeah.
Right. And so that technology is called containers and is only available on Linux. For instance, you don't have Windows containers.
No.
Right? You cannot have like a Windows VM run you cannot have a Windows host run a Windows VM and have that VM ask the host, hey, can you give me some stuff so I can have less overhead? No, you can't. That's not possible. So with Windows, you always have full overhead.
Okay.
All right. I mentioned Docker, and I mentioned that Docker actually runs. So Docker is a container framework, and it technically does run on Windows as well, but it doesn't make much sense to run it on Windows. So when you run Docker on Windows, and this is where we stopped, when you run Docker on Windows, what ends up happening is you're actually just running virtualization software. So the way it works is you have your normally here is what happens with Docker. You have your Linux operating system, your host operating system. And inside that host, you're going to be running the Docker daemon, the Docker application. So here we're going to make Docker, a bit of a magic box, Docker. And what Docker is going to do is Docker is going to say, okay, I'm going to create containers. So those are like separate instances of Linux.
Okay.
And Docker, the app, is going to manage those containers, those Linux containers. But for instance, if we look from a physical perspective, we only have one machine, right? We only have one physical machine. But from a logical perspective, it behaves a lot like VMs, virtual machines, where from a logical perspective, it's like we actually have 5 machines, 5 operating systems running.
Yeah.
And what's going to happen is, let's say that this is the Linux core. So I said that containers sort of need access to the Linux core. That's not exactly true. They actually have access to a lot more than the Linux core. For
Okay.
instance, like a lot of daemons, essentially, a lot of, how would I explain that? A lot of applications running on Linux that require administrator access. So things like the clock, for instance. Clock is a good example. So let's say your Linux host has a clock, right? So it says it
Yeah.
is like 9 p.m., for instance. So the Linux host has a clock. Then every other container here, instead of having their own separate clock, they're just going to refer back to the clock of the host.
Okay.
And you have a bunch of systems like that where the containers don't do it themselves, they just ask the host. And you don't have to run the same piece of software multiple times.
Okay.
If you were to make virtual machines, each virtual machine has its own dedicated clock, even if they're Linux virtual machines.
Well, then how does Docker work with Windows?
That's a great question. The answer is it kind of doesn't.
Then
So
what's the point of having it?
it does work. It does work in the sense that Docker is made to manage Linux containers. From what I know, to my knowledge, it's not possible to run Windows containers in Docker. It might be possible, but in which case I believe it would just create a virtual machine anyway, because I don't see how that'd be possible. But in the case of Docker on Windows, you'd have the Windows operating system. You'd have the Docker app or Docker daemon.
Yeah.
And then what Docker will do is first it will create a Linux VM, right? First it will create a Linux VM. And then inside that Linux VM, it'll actually create containers.
Okay.
So like you have that extra layer, right?
Yeah.
Right. This is why, by the way, and I guess this is more of a piece of trivia than anything. If you're interested in trying Docker out, which I recommend you do, it's very interesting. But I guess it requires a bit of some knowledge on Linux. But if you ever want to try a Docker, if you want to install Docker on Windows, Docker for Windows requires Hyper-V, which is the Windows. It's the Windows hypervisor. It's the Windows hypervisor.
Okay.
Right? So it's a virtualization software that can come natively with Windows 10. And I believe it doesn't necessarily come with every edition of Windows, though. You can't really. I don't know that you can just download it from anywhere. I believe it's a service you have to activate, and it's a bit of a mess. But if you want to run Docker on Windows, you need to get Hyper-V to work on Windows, which makes sense because you're going to be running a Linux VM.
Yeah.
Okay. Was there anything else we talked about?
Well, the use of virtual machines in an enterprise setting.
Yeah. So this is where it gets really interesting.
And so we said that instead one application needed its own OS.
Yeah.
And
Why is that, by the way? Why does one application need one OS?
Because we don't know how it will react with other applications.
Exactly. Like sometimes on your own PC, you've installed multiple applications, and sometimes you've installed something that changes the way another software behaves, and you need to fix that. We
It
want to
just
avoid
becomes
that kind of shit.
fast.
Yeah.
And so, well, we had an example where we had an HTTP server
Mm-hmm.
with one application, an
Right.
FTP server with one application, then a Minecraft server. And each one of these servers, they weren't like at its best performance. So like the HTTP was only using 10% of the CPU, FTP 20% of the CPU, and Minecraft 50%. And we said that in the end it's going to be very expensive because that just wears down the hardware.
That's
And
not really the point. It's more like we just paid for 3 servers, 3 physical machines,
on the
and we're not
physical,
even using half of their compute power.
yeah.
The point with wearing down the hardware was unnecessarily running desktop computers all the time,
Oh,
right? It was something else. Here, technically, actually, if you look at it, virtualizing. So what we want to do is the advantage in an enterprise is you want to run all these, like you want to run separate applications on separate operating systems. But now what you can do is run multiple operating systems in one physical machine and have that one machine be at 80% CPU utilization. Usually you want to sit at 70% is a good
yeah,
place to be, because like you have enough margin if you have a burst of CPU utilization, and like you're using a lot of what you actually paid for, of the components you paid for. The
yeah.
thing is, this machine being used at 80% will wear down a lot faster than these machines used at 10, 20, and 50. But the
But we
fact that it wears down faster does not justify the fact, like, does not justify purchasing 3 of them.
no.
Okay.
And so that was one of its uses in an enterprise.
Honestly, it's the main one. But yeah, there was something else, right?
And afterwards, we talked about how developers could use it.
Yep.
And so there's two different OS, yeah, OSs in a sense, because with the developer
Environment. I use
OS
the term
environment,
environment.
sorry, yeah,
Right.
with the developer environment, there's all the software for developing,
Yep.
but
So
afterwards,
so on the software environment, you have like all of your development software. You have perhaps also, because it's probably a personal computer that, like, not necessarily personal, but like there's a human being using that computer. It's likely
yeah,
there is like a web browser, some search history, maybe some extra, video conference tools. Like you don't know what's on that computer. There could be anything.
yeah, and afterwards there's the production environment, which has all of the production software.
Yep.
And so even though these two computers might run Linux, the application on the developer environment won't be compatible with the production environment.
So it's not that it won't, it's that it's very likely that it, like, there's a serious chance that it won't, rather.
Okay.
Like if, oh, like in a perfect world, the application you are developing as the developer, on your own PC,
Yeah.
with any chance you've actually, what you're doing perfectly and you never make mistakes, and your developer in your development environment perfectly like, exactly the kind of interactions you're going to have between all your software, and that what you're developing will fit the production environment. No one is that good, right? Unless you understand perfectly everything about your own environment, it's like you can't. Like there's always a chance that whatever you developed on your developer environment won't be compatible with the production environment.
And so a virtual machine can be used to make a development environment very similar to that of the production, so that we can have a good idea of how it will run.
Yep.
And so if we develop the app on this virtual machine, we can use a snapshot which sort of like copies this application in this environment and tells this production environment to run this snapshot so that it runs this application in this. I don't know how to explain it.
So what we're trying to do here is to say, first of all, it's very likely that the production environment is actually virtualized.
Really?
Well, yes, obviously. Like we explained,
Yeah.
there is essentially no reason not to do it.
Yeah.
So, like, we have, like, let's say this is our production server. It's actually a virtualization server. And it's going to run a bunch of Linux VMs, right? Or maybe even containers. If they're all Linux, why not just do containers? They're much smaller, right? Much less overhead. So the server runs a bunch of Linux containers inside a Linux host, right? And what you can say is, well, this one here is this. Hold on. You can say this container here will be dedicated to whatever app I'm currently developing. So what I can do is just say, okay, please give me like all the details on how you created this container, and I will copy, like I will create the same container on my own developer machine.
Yeah.
And then what I can do is just say, okay, I'm done developing the app. Just push it to the server directly, right? The only slight differences that we might encounter are things like compute power and things like that. Like hardware differences. You might have hardware differences, but normally, if you've managed your containers properly, there should be no difference in environments between the development environment, like the development container that you used here, and the production container. Like they should be the same.
Okay.
Right. And one very, very much used tool to do that is Docker, right?
Yeah.
Like if you're a developer, you're going to be using Docker 100%. Okay. Well, that's a good summary of everything we've done so far. So now we need to get a bit more technical. I hope, like, yeah, like this wasn't technical enough.
Hold on, I'm starting to take notes now.
Yeah, that's a good idea. I can send the whiteboard your way if you want, and obviously the VOD will be available on YouTube.
If you don't mind, actually.
Okay.
Yeah.
So now here's the question of, okay, that's all fine and dandy. Those are the principles of virtualization. You know, you have isolation and some flexibility in your backups and all of that.
Yeah.
But then, okay, how does it work? Like, how do you actually virtualize something? Well, fundamentally, it's a piece of software. It's like you have your host and you have your operating system, right? Your operating system is running on a physical machine, right? A physical machine which has a CPU, motherboard, GPU, some RAM, an NIC, which stands for Network Interface Card. So it's like your
Okay.
Ethernet port, essentially.
Oh.
So those are physical resources on your host. What your operating system does normally is just like communicate with each of these components.
Yeah.
Right. What we do when we do virtualization is we say, okay, I would like this virtualization software or container software. So it could be Docker, could be Proxmox, could be VMware Workstation, VMware Player. You tell the hypervisor, okay, please create a virtual. First of all, you need to create the virtual physical machine, the virtual hardware. So that virtual hardware is also going to have its own virtual CPU, virtual motherboard, virtual RAM, and so on.
Okay.
And in fact, what's really cool about it is that, for instance, in the case of network interface card, you can give it more network interface cards, virtual network interface cards, than you have physical network interface cards.
Oh.
Yeah, we'll get into that, but it's really cool. That's where it gets really, really fun. And we will do some of that later for our labs. So you need to give it. So first, you need to create the virtual hardware, and then you can tell the virtualization, the hypervisor, now install an operating system on that, right?
Yeah.
First, create the virtual hardware, then install an operating system on it. So what I want to focus on now is actually that virtual hardware. There is so it is a real huge rabbit hole that I'm not gonna fall into. I'll just go over some of the most important components of virtualization hardware. So a big thing is actually the amount of CPU cores you have. So for performance reasons, you want like you want your virtualized hardware, you want your virtual CPU to be as closely tied to the physical CPU as possible.
Okay.
In fact, there is a technology that's called, I mean, the general term for it is pass through. This is not quite what we're doing here, but it's close enough. It's a good analogy. Where you're saying, for instance, GPU pass through is very common, especially for like gaming VMs, where you'd say, hey, take my GPU and don't use it on the host at all. Like, literally, don't use it on the host at all. Just give it to the virtual machine, and only the virtual machine can actually use it.
Okay.
Typically, that's what you can try doing that if you want to run a Windows virtual machine. Hold on, I got someone to bed. There we go. So this technique is called pass-through. It's a whole rabbit hole. There's you have very specific sort of hardware requirements to do it. So I would only recommend doing it if you really know what you're doing. It's not trivial. GPU pass-through specifically. In the case of CPU, we don't need to do in like complete pass-through. We can do something that's slightly more simple, but so for CPU, there's another technology that is not quite as good as pass-through, but is still very, very, very good. And you enable that in the BIOS settings, and often it's called CPU virtualization. Virtualization. And this is an option you enable in your BIOS. So you need to enable it. And what this does is it says, okay, like it essentially, so I don't know precisely what it does from a technical perspective. What I do know is that it allows the virtual CPU to communicate more directly with your physical CPU and improving performance. So you want to, okay, you want a direct line essentially between your virtual CPU and your physical CPU. Essentially, right? Then, okay, we need to take a look at like what your physical CPU is made of, right? So let's zoom in on the CPU because a lot of our talk here is going to be about CPU. So first of all, can you explain to us what a CPU is?
CPU is the brain of a computer.
Mm-hmm.
It is most. They have cores and threads. Well, they have cores,
Yes.
and in those cores there are threads. Each
Mm-hmm.
thread is assigned a task,
Right. Okay, that's pretty good.
And so the more thread you have, well, normally, I'm not sure, but this is what everyone has been telling me. The more threads you have, the better it is, or the more cores you have in general, the
Depends
better it is.
depends what you're trying to do.
Yeah. So that's why I said I think.
Right. So this is pretty good. Like this is a pretty good introduction. So yeah, the first thing is the cores. So you have two important, like the two most important metrics to measure what a CPU is capable of is the amount of cores, number of cores, and the clock speed,
Yep.
right? Clock speed. Can you explain to us what the clock speed is?
It is, well, I guess how fast your CPU, how fast or how performant your CPU can be.
So it's actually, so the reason it's called clock speed, it's a weird name, right? Talking
Yeah.
about clocks. Um, the reason it's called a clock is because, so okay, I'm gonna do a very simple demonstration of what a CPU core looks like. Like this is super abstract, okay? But like
Okay.
we're gonna talk a little bit about it. We're gonna do a tiny bit of electronics here. So in electronics, we have what we call gates, which are logical gates. One of these gates is the invert gate, which means whatever signal is inputted is inverted. The output is inverted.
Okay.
Okay. So then what you can do something cool where you say, okay, I'm going to input a signal for like a very short amount of time, right? So first one is means there is a signal and 0 means there is no signal.
Okay.
So I say, okay, I'm going to input a signal, meaning the output is 0, right? And then I'm going to cut the signal. And then the output becomes 1. But wait, hold on. We've linked all of this together, right?
Mm-hmm.
So if the output becomes 1, it means shortly after the input actually becomes 1 and the output becomes 0. But it means that then the output becomes 0 and the input becomes 0 and the output becomes 1, and so on and so forth. And so you go back and forth to doing 0 1 0 1 0 0 1 really, really fast.
Okay.
This is what we call a clock cycle. A clock cycle is when you go from 1 to 0 and from 0 to 1.
Yeah.
And so when you, for clock speed, so this device here, this little heart, you can think of this as like the heart of the CPU. It's like it rebeats, it has a clock. It is a clock, right?
Okay.
So this is what we call the clock. And clock speed is measured in gigahertz, I mean in hertz. And hertz means how many times per minute. So for instance, a clock that is, I don't know, let's say 2 gigahertz, it means it's going to do 2 million, no, 2 billion, excuse me. It's going to do zero, is going to go through 1 to 0 and then 0 to 1 to 2 billion times per second.
That is a lot.
Yes, it is. Obviously, this is extremely simplified because then, like, the you can essentially get more power, more computation from a single clock cycle. If you like, I think it's between Zen Plus like for AMD processors, between Zen Plus and Zen 2 architectures,
Yeah.
you have like I believe it is 15% more compute power per clock cycle. So even though at the same clock speed, it would be like you have 15% more clock speed.
That's a big improvement.
Yes, it is. Like Ryzen 3000 series is no joke.
Wait for 4,000.
No, man, I'm waiting for 5000 with DDR5 memory.
True. True. Fair point.
So, okay. This is essentially like this is an oversimplified. So this is a clock, right? And then
Yeah.
you've talked about cores. The idea is that in your processor, you have multiple cores. Each core has one clock. I'm going to draw a clock. So for instance, if you have a 4-core processor, your 4-core processor is going to have 4 cores, each of which has a clock. So a little device like this that goes through ones and zeros really, really fast.
Yeah.
And then the really cool thing about this is that if you have, so like you explained, yeah, if you have 4 programs, normally if you have only one clock, well, one clock can only do one operation at a time, right?
Yeah.
Going through a 1 from a 1 to a 0 to 1, so a clock cycle can only do one operation. So if you only have one core, one clock, you can only do one operation at one given time. The
Yeah.
advantage of having multiple cores is that suddenly you can do multiple operations at once.
Okay.
Right. So for instance, in the most basic example, we have 4 cores. That means we
Yeah.
can run 4 threads. And this is what you talked about. A thread is like the measure of how many applications, how many operations can I do simultaneously.
Okay.
So with just what we've seen so far, if I have 4 cores, I have 4 threads. That means I can run 4 applications simultaneously.
Yeah.
If I have more, let's like if you open the Windows, like it's the, let me see, I can show. Okay, yeah. If you check this out, if you check your task manager and you go under performance, you can actually see the amount of threads running on your machine right now. And you see it's 3,000, for me it's 3,000 something. Obviously,
Yeah.
I don't have 3,000 cores. What it means is that there are 3,000 and something tasks running simultaneously on my computer.
Okay.
And then, so this is like from an operating system perspective, a thread is like a task. And then when your computer is, my computer is like, wait, hold on, I don't have enough cores to handle all of that. Essentially, the way it works is, so let's say I have 3,000 tasks. Is gonna one core is gonna handle one task for a given time, and then it's gonna pause it. It's gonna pause, and then it's gonna run another task, and then it's gonna pause, and then it's gonna move on to another task, and then it's gonna pause. Right? So I can only run, like the amount of tasks I can run simultaneously is dependent on how many cores I have.
Yeah.
Otherwise, I have to like pause in between tasks, in between handling tasks. Now, on top of that, there's another technology called hyperthreading. I suspect you've heard of it.
Hyperthreading. Yeah, I've heard of it, but I haven't looked into what it can do or what it is.
Threading. So hyperthreading, I'm not aware of the actual technical details of it. Again, I'm not so big on hardware. I'm more of a network guy, but my understanding of that is that when you have hyperthreading enabled, each core is capable of handling 2 threads, 2 separate threads. Right? So suddenly a 4-core process, this is why, for instance, if you check an AMD CPU that would have 4 cores, very often you'll see 4 cores,
8 threads.
8 threads, right? That means 8 threads. That means hyperthreading is enabled. Hyperthreading is something you can disable, by the way. And disabling hyperthreading increases your single thread performance.
Yeah, okay.
Right? So, for instance, hyperthreading is extremely useful for multitasking. But it's not always an upside. So I'm not aware of like the technical details of how it works.
Yeah.
But fundamentally, you can get, for instance, for heavily single-threaded applications, so that means one thread requiring a lot of process. So something like most video games, with a few exceptions, such as I believe Apex is actually an exception to that rule. It's more multi-threaded. But for single-threaded applications, like most games, it would be beneficial to disable hyperthreading, go back to 4 threads, but then having each one of those threads be more powerful.
Okay.
Right? By the way, this is why. So if I show you my CPU performance again, so I have a Ryzen 3900X, which is a 12-core processor. But if you count here the numbers, like the amount of graphs here, you can tell I have 24 graphs. Why do I have 24 graphs when I only have 12 cores? Well, it's because from the perspective of the operating system, if hyperthreading is enabled, then each CPU thread, each hyperthread actually appears like a separate CPU core.
Okay.
If I was to disable hyperthreading, I would not see 24 cores here, but only 12. The 12 physical cores that I have on my processor.
Yeah.
Okay, so all that talk, now we understand. So if you open up your own task manager, I want you to tell me how many threads you have right now. Like how many threads does your CPU have?
Well, for now I only see one giant graph, even though it's a 6-core
Oh,
processor.
let's see. What's the option to? I don't remember what the option is to. Oh no, I didn't mean to do that. Oh no, that's terrible. What did I do? I can't even right click anymore. This is horrible. Do I press enter? Double click? This is horrible. Jesus, Windows. Okay. Okay, I just reopen it. Oh, there we go. No, that's not it. Hide graphs? Show graphs? No. I don't know. There is maybe options. Right click on the graph and reset to logical. Oh, maybe this one. Yeah, this is what you see,
Yep.
right?
Yep.
Okay, so you right click it, change graph to logical processors.
Okay. It is showing me 12 supposedly CPUs when it's actually the threads.
Right, so if it's showing you 12, then it's likely that you have 6 cores with hyperthreading enabled.
Yep.
Okay, so the really cool thing that we can do now,
Yeah.
in relation to virtual machines, is what we're going to have to do is we're going to have to give each VM. So if we go back to our VMs here, and again, what we care about right now is the virtual CPU, right?
Yeah.
When we configure our virtual CPU, we can give it a number of cores. We can say 1 core, 2, 4, 8, and so on. In fact,
Yeah.
if we have CPU virtualization enabled,
Yeah.
those cores will actually correlate to cores on our physical machine. So for instance, if I say, hey, I want this to have 4 cores, in fact, it will correlate to 4 logical cores. So that means 4 threads on my physical CPU. So 2 physical cores. Does that make sense?
Yeah.
Okay. So what you have right now at your disposal is a machine that has 12 different threads, meaning if you were to run virtualization and you want somewhat decent performance, you could run up to 12 separate CPU cores. So if you want, let's say you want like just one CPU core per VM, which arguably is fine because we're going to be running rather weak, I want to say weak VMs, like not very CPU intensive. If you just want to run one CPU core per VM, you're actually going to be able to run 12 of them.
Okay.
In practice, you can run more because because it's not pass-through, right? Pass-through means the VM has exclusive access to the CPU core.
Yeah.
Whereas if you have CPU virtualization, it just means, hey, please copy the configuration of my CPU for better performance. It's not essentially we want CPU virtualization And a good rule of thumb is that you don't want to exceed, like if you run 12 VMs with one core, you're very, very tight, right? You definitely don't, you want to avoid exceeding that.
Definitely.
Okay. It's not that it won't work. It's just that the more you're going to be using those VMs, and the more you're going to run into performance issues.
Okay.
Like serious, because essentially they're going to be stepping on each other's toes.
Yeah.
Okay. So, now that we know that, it means that for you watching at home, if you're interested in virtualization and you are wondering what can your physical machine run, the main thing that you want to look at is the number of cores. Yes, the clock speed will matter, in the sense that the more clock speed you have, and like it will increase not only the performance of each individual VM, but also technically it might increase the amount of VMs you can run. But in practice, you don't want to exceed, like a good rule of thumb is not to exceed the amount of threads you have available. And again, if you want to see how many threads you have, you go in the task manager, right? So this is the task manager, go in performance, check your CPU after clicking, logical processors for the graphs, and you can tell how many logical processors you have. You don't want to exceed that number. So I have a very good CPU. I have 24 logical processors. I could easily run 24 separate VMs.
Yeah.
Okay. How to make a virtual girlfriend? I don't know. Ask Elon. So now I think we can actually get to it. Now that we understand this. Also, yeah, no, hold on. Before we do that, I also want to mention one more thing regarding virtualization. I mentioned something that got you a little excited, that you can run VMs that have more NICs than you have physical NICs,
Yeah.
physical interfaces. So the idea is this. You have your and this is what I do personally with my home server. You have your physical machine, you're running a virtualization software, running Linux. So like this is a hypervisor, Proxmox, for instance, the one that I mentioned earlier. You're running separate virtual machines, right? So first you have the virtual hardware, and then you have the virtual software, and then you have the operating systems inside. But what I care more about, hold on, I'll just close the window real quick. I'll be right back. Definitely want to avoid insects flying in.
Yeah. Isn't exactly the most agreeable thing in the world.
Yeah. So what you can do is say, okay, I want a network architecture where like these two PCs are connected to, like all PCs are connected to this one, and this one is actually connected to the physical network interface card I have on my physical PC. Right?
Yeah.
So suddenly, well, this VM here has like four network interfaces, right?
Yeah.
Even though it's only using one. But that's because you're now virtualizing an entire network. And that's what we're going to do when we do the VPN lab. We're going to be virtualizing that, right? We're going to have, essentially what we're going to have when we do the VPN lab is we will have 3 computers, 3 operating systems. And they'll be connected like this, right? Where we have, this will be our PF sets. This is our firewall. This will be our Windows machine, and this will be our Linux machine.
Okay.
All right. So now I think we can actually just start getting to it. So you said you've downloaded all the stuff I've asked you to?
Yep.
All right. I'm going to ask you to launch VMware Workstation.
Oh,
So this is VMware Workstation. This is the virtualization software. This is the hypervisor we're going to use to create VMs. As you can see, I already have like a bunch of VMs. They're obviously not running they're not running right now.
Is the VMware workstation like WinZip, where you can just constantly say I don't want to pay now?
Oh, hold on. Yeah, no, never mind. Launch VMware Workstation Player, if that's what you're asking about.
Okay.
Like, make sure
Okay,
you
yeah.
run that one.
Non-commercial use only.
Yes, exactly. And by the way, what we're doing now does not qualify as commercial use. It's educational. Also, okay, hold on. Before we move on, just why am I using VMware? So if you look around, you will see different virtualization software. One of them that comes back very, very often, especially in the case of beginners, is VirtualBox.
Okay.
VirtualBox. I do not recommend VirtualBox. It's not a bad virtualization software, but it doesn't have. It has very, very few features. Really, it's like made for beginners, but it's so beginner friendly that you have no control like you have very little control over what you do, in my opinion.
Wow.
I don't like it. I mean, it's not that simple, obviously. You'd still have a lot of things to figure out with VirtualBox, but in my estimation, if you're going to be using virtualization software, might as well just use the proper one right away.
Well, okay, yeah.
All right. So hold on, I'm thinking. Okay, yeah, I'm gonna change scenes to make sure that this is very visible to the stream. So what we're gonna do is we're gonna create a new VM. So we go to player, file, new virtual machine. Simple enough. Right?
Okay.
Then what we want to do, so you remember all those ISOs that I asked you to download?
Yeah.
Right? So which one do you have? Do you have like Pop OS?
Should have been one of the ones that you told me to download, so yeah, normally.
Right,
Yeah, Pop
right.
OS.
Okay. So start with Pop OS. Pop OS is a Ubuntu based Linux distribution.
Okay.
One that I personally really like.
Okay.
Okay. And then we click next. Then it's asking us for, details. So this is VMware's way of trying to optimize software, optimize the virtual hardware a little bit to like pre-configure it. So like we can give it details, and it is a Ubuntu based distribution. So leaving Ubuntu here is fine.
Okay.
Because it is like if you look around, you will not find Pop OS, but you will find Ubuntu 64-bit, right?
Yeah.
Because it is close enough. And we hit next. Give it a name. This is good enough for me. Give it a location for where all the stuff is going to be stored. Good enough for me. You give a disk size. So the disk size it's not set in stone in the sense that if you create, like, for instance, 100 gigabytes disk, that doesn't mean it's going to take 100 gigabytes out of your hard drive right now.
Yeah.
It says that as the virtual machine requires storage, the file that represents the storage will get bigger up to 100 gigs.
Okay.
So I like 100 gigabytes. It's flexible enough for me. And then what we want to do is customize hardware. And this is where we sort of, you see how we have memory. So we have our RAM, our processors. We have a bunch of stuff here. So the first thing we want to look is RAM. So how much RAM do you have on your machine?
20 gigabytes.
20 gigs. So you can run 4 gigabytes. It's absolutely acceptable. You can go much higher if So depending on what you're going to run on the VM, you might need more RAM. For what we're going to do, 4 gigabytes is just fine. We could even lower it to 2, but it wouldn't make sense to do that either. 4 is fine.
Okay.
Now let's look at this. So this is this is the amount of threads that the virtual machine is going to be using. And you see it goes up to 16. There is like a limit here, which is kind of hard coded. It's kind of a shame. But personally, I like 2. Either 2 or 4. So you said you have a 6-core processor, right?
Yep.
So you have 12 threads. We can do... Let's do... hold on. I want to make sure I don't... 4, 2... Let's do 2. So 2 processors. And what you want to click... You don't want to click that. You want to click virtualize Intel VTX/EPT or AMD V... So these... Remember when I talked about CPU virtualization?
Yeah.
So you have to enable it both ways. You have to enable it in the BIOS. So hopefully it is. If what you're using is a desktop computer, it is likely to be enabled, but not certain. If it's not enabled in the BIOS, that's fine. We can still disable this. So you have to enable it in the BIOS, and you have to enable it in the hypervisor as well.
Okay.
Right. Then you have a reminder on the ISO file that you're using.
Yeah. CPU virtualization disabled.
So if you disable it, you're gonna likely have worse performance. Not that it's a big deal, but usually it's a good idea to have it enabled. If it is enabled in your BIOS, make sure to enable it in the virtual machine as well. There is like no downside not to. Oh, well, that's not exactly true, but
It's better.
I mean, yeah, generally speaking, it is better.
Okay.
And then network adapters. So for now, we're going to leave it at NAT because this is way more about networking than it is about anything else. So we're not going to deal too much with this. One thing that I will mention is that you can actually add hardware. You can, for instance, add another network adapter. See, so now I have 2 of them.
Okay.
And I can use LAN segments to sort of connect different VMs together. And this is what we will do when we do the VPN lab. For now, I only want 1 network adapter though. And then you have stuff like printer. We can remove it, it's fine. Like you can leave it in, you can remove it, it doesn't really matter. USB controller. USB controller is good to have because essentially it makes it so when the VM is running, if you plug a USB drive or any USB device actually in your physical computer, the VMware will ask you, hey, that thing you just plugged in, do you want it to be connected to the virtual machine? And if that's the case, which virtual machine? Because maybe you're running multiple of them. Or do you want it to be connected to the host? So that's really cool. You can have your like physical USB drive communicate directly with the VM.
Okay.
Regarding displays, so I don't think you want to touch these settings. It's just I'll just mention one thing. The display, the way the display works in a VM that we're just gonna create like this, the performance are not good, and so you're never gonna you are unlikely to run any game on this. Like you're lucky if you run Minecraft, and I'm not even sure that you can run any game because I believe that this is a specific software display adapter, virtualized display adapter, which isn't necessarily compatible with things like DirectX.
Yeah.
So you're not gonna run Shadow of the Tomb Raider with that. However, if you do want a gaming VM, I've alluded to that earlier. What you can do is do GPU pass through, and that's actually the most efficient way to do it, where you're essentially telling your computer, hey, give the virtual machine full access to my physical graphics card. And then your HDMI ports or display ports coming out of your graphics card Like they will display the content of your virtual machine.
Okay.
So that's a really cool thing to do if you've got like a week to put into that. All right, and I think we're mostly done. So now we're going to close this, finish. And there we go. Here's our virtual machine. We want to run it, play virtual machine. And then what's going to happen is we have a like very simple version of a BIOS. And then this is just Linux doing its thing. This is Pop OS booting up. And if we were to run Pop OS on our physical bare metal install, we'd have exactly the same thing. We'd have the same screen. We would be seeing the same thing. Oh, also on VMware, in some cases you do not have, like in VMware, in some cases you don't have access to your cursor because maybe you're stuck in a command line or something. You can always do Control Alt to like focus out of the virtual machine if needed. Like to go back to your host. If you're stuck in the VM and you can't get your cursor out of the VM, you can just do Control Alt, and it works most of the time. Not always, unfortunately. So here, and this is just Pop OS booting up and asking us, hey, do you want to install it?
I've run into never.
I
need to turn on the CPU virtualization.
Oh, did it not work because you didn't have it turned on?
Nope. Ever while powering on, the host supports AMD, but AMD is disabled, and when I had it enabled, it said that CPU virtualization wasn't on.
Okay. Oh, so you're saying that you need to reboot your computer and enable it in the BIOS, right?
Yep.
All right. Well, you go ahead and do that, and we'll be waiting.
Okay.
See you in a bit. And we are back. Sorry to keep you waiting. Welcome back. Hello, Trailmix. Do you hear us?
Yep.
Okay, great. And here we are again. So, did you manage to get the VM running?
Yep.
Do you have like a similar screen to what I have? Or are you getting there?
Yep.
Okay, well, fantastic. So this is where it really becomes like, this is where you see what virtualization is about. What you have under your eyes is how this specific Linux distribution would look like if you were to install it directly on your machine. You would have the exact same thing on your screen.
Oh, wow.
Yeah. Oh, wow. So let's just run through some of the configurations. I'm just going to set the French layout because I have a French keyboard. But aside from that, we're going to keep most stuff probably default. So, okay. This is where there's a major difference between doing virtualization and doing things like dual boot or having multiple hard drives with multiple operating systems. So if I wanted to do dual boot, I would do custom, right? I would tell hold on, let me do something real quick. I would do custom here. I would tell the operating system, hey, I don't want you to just wipe what I previously had. I want you to like install yourself alongside it.
Yeah.
That's what I would do if I wanted to do dual boot. That's what I would do also if I had multiple hard drives. I'd want to tell it, hey, I want you to get installed on this specific hard drive.
Okay.
Right. In our case, we don't really care. We've given it a virtual hard drive of 100 gigabytes, so we can just do clean install. And it's actually gonna, it asks us for which hard drive we want to install it on. So this is the hard drive in question. And we just click erase and install. So it's gonna wipe the drive, which is already empty anyways. And on our host, that drive is just a file, right? We do erase and install. we can skip the encryption, and there we go. We're installing Linux right now.
Oh, nice.
Yeah. And so if you want to start getting comfortable using Linux, so you want to practice, the console line and stuff like that, well, just run it on a VM and it'll work just fine. If you feel like you don't have enough performance, you can increase the amount of cores. If you feel like you need more RAM, you can increase the RAM. And you can do that in the, let me show you real quick. So in this screen, if you want to modify, let's say you want to modify the virtual hardware of a virtual machine. So for instance, for this one, let's say I go to settings and I say, okay, I want to increase the amount of RAM, right? Wait, can I? Oh no, I can't do that because it was running. Okay, hold on. What about Windows? Okay. So edit virtual machine settings, and I can give it like more RAM if I feel like it's needed, or less. I can increase the number of processors. I can, I have access to this screen again, right? I can add more hardware to it.
Okay.
So this is the same screen we had earlier, which means if your virtual machine, if your hardware needs for one given virtual machine change, well, you can just change it. Because this is also the power of virtualization, is you can change the virtual hardware to match what you need. And then, so once we're done installing, we could just restart device, which is obviously only going to restart the virtual machine, not the host.
Yeah. At the bottom, it's telling me about VMware tool.
Yes, so you don't need to install them, but if you want to install them, you'd have to do that after you're done installing the operating system.
Okay.
Personally, I have struggled even managing to install them, so I don't even bother with them anymore. I'm not exactly sure what they do either. Okay, disable location services, time zone. You can link your account. I'm not about that life. Right, so username, you're creating an account, let's give it. And also because it is a virtual machine and not like a physical machine, I personally feel absolutely fine because this is just like a test machine, right? I feel fine giving this virtual machine like a bullshit password. I don't care. What I care about is like the physical host, like the host operating system. That one I want to secure. But like the VM, if it's just a VM for me to test things out, I don't need to secure it. I don't care. I really don't care. And there we go. I'm done. I'm finished installing Linux. It's just going to run a couple of things. And there we go. It's done installing it. Now I have access to everything, including like the infamous Linux terminal, the very scary part. And then, if you're interested in Linux, we can we can definitely do some classes on it. I'm not a Linux expert, but I do use Linux a fair bit, so we could do some stuff here. And you also have plenty of resources online on what to do with Linux, how to use it.
Okay.
Like you really have plenty of resources. I think it's best to use Linux with an aim in mind, like, oh, I want to do something with Linux.
Yeah.
Right. Like for instance, really cool thing that you can also do. So remember I mentioned that Proxmox. Do you remember when I mentioned Proxmox?
Yeah.
It is a type 1 hypervisor. It's a hypervisor operating system. But it's an operating system, right?
Mm-hmm.
So I can run it in a VM.
Yeah, you could.
So this is what we call nested virtualization. Is when you do VMs inside VMs. And it's actually a fairly common practice.
the real computerception evolves.
Pretty much, yeah. Now you have to account for the fact that every time, like every layer of virtualization adds some overhead,
Yeah.
right? So you cannot do that infinitely. But it's so in my case, it would be interesting, for instance, for a lab, one of our labs, if we actually create a Proxmox virtual machine, and then in that Proxmox virtual machine run a bunch of virtual appliances. And then everything would be on like one single virtual machine instead of being on separate ones.
Okay.
It can be useful, for instance. So if you ever want to run a home lab, so let's say, for instance, I have a home lab here, and I'm running a Minecraft server, Terraria server, a few web servers, a NAS as well, which is a file server. I'm running a bunch of stuff, and all of that is running on a single machine, on a single server. And this is what's really cool about virtualization also, is that you can run an entire infrastructure off of one single machine. And that can be like an old, that can be just like an old PC. Now, obviously, virtualization, virtualization servers tend to require, like in terms of proportionally, they require more RAM than CPU compared to desktops, in my experience at least. Because every operating system needs like a few gigs of RAM, but not every operating system is actually going to be requiring a lot of CPU.
Okay.
So like my virtualization server has like a 6-core Ryzen CPU, but it also has like, I believe, 24 gigs of RAM, which is way more than what you like. If I was to run a desktop computer with with that Ryzen CPU, 24 gigs of RAM would be completely overkill. But because we're running a server, the CPU isn't quite as important as the RAM. Like we don't proportionally, we need more RAM than CPU. And yeah, that's it. So if you want to run your own, server, I heavily recommend that you run through it. You go through a hypervisor. You also have a bunch of options for hypervisors other than, Proxmox. Let's see. You also have things like Unraid, which is a paid subscription service, but I've heard very, very good things about Unraid. Really, really good things. If you can put money into it, it's probably worth it.
Okay.
You can run Unraid. You can run. There's also FreeNAS. I believe FreeNAS also does virtualization. What else was there? Is it? I don't remember. Some kind of media. I don't remember what it's called. Some kind of home media server software. I've forgotten what it's called, but another like open source home media server that can do virtual is also a type 1 hypervisor. Personally, if all that you're interested in is like bare bones virtualization and you don't really want too many features, I like Proxmox. My personal choice. It's free, open source. As far as I'm concerned, it works just fine. And also, it's a Linux core, meaning like you can access the Proxmox Linux command line itself, like the command line of the hypervisor.
Okay.
What we also call the CLI, the command line interface. You can access it directly. So, yeah, that's it. Let's check out how our VM is doing. If we're done updating, what I'm doing right now is essentially updating the Linux VM.
What command did you use for that?
So I used two commands. I used sudo apt update, and then it asks me for my password, and then sudo apt upgrade. If you want more details on what those do, I suggest, honestly, you have plenty of really good guides online. And I don't necessarily want to delve too much into how to use Linux. Not right now.
Okay.
And there you go. So do you have any questions?
What's the next step?
Well, our goal was for us to be able to generate virtual machines and make virtual machines, understand how they work, understand the context in which they would be used, in particular, like whether it's a consumer context or an enterprise context.
Yeah.
I believe we've done that. I believe we've done all of that.
Okay.
The next step would be later on, once we actually want to do labs for other topics, we're actually just going to be using VMware as a tool to run our labs.
Okay.
But I think that'll be for another time. So, what do you think?
It is interesting.
Mm-hmm.
It feels weird to run Linux, something I'm completely new to, at the same time while having my Windows OS available at any moment.
Right. Like the first time when I discovered it, I was like, "Damn, man, this is so cool!" It's like I'm no longer constrained by one operating system at a time. I hate Windows because they're pieces of shit, and I wish I could use Linux more often. Yeah, but I can't run games on Linux, so I have to use Windows,
Yeah,
right?
yeah,
So personally, I use Linux quite a bit. I use like you can see, I have a few VMs. I use them very often just to lab things out. Like recently, I was testing out a um, open source SDN controller called Onos, which is essentially it's just a Linux app as far as you're concerned. It's a Linux app that I wanted to get my hands on. Well, just create a Linux VM, install it, and see how it works. It's
yeah.
really that simple. That's fucking fantastic. So the really cool thing is now, let's say you want to get into programming, right? You want to learn programming, you want to learn development. Very often, most developers have a Linux environment.
Yeah,
So what you can say is, okay, I don't want to install Linux on my machine because I still want Windows to be the bare metal install. But you can set up a Linux VM with like you have 12 threads total. So maybe you give it like 8 threads, you give it quite a bit of, compute power so that it's not too sluggish.
yeah,
And then you code on that.
yeah. I
And
can see the use.
yeah, definitely. Like anything that you install, like the day let's say you completely fuck up your VM, right? Well, that's
Yeah,
fine. You can, first of all, you still have access to the disk content, even if you can't boot the VM. Because at the end of the day, the disk is literally just a file on your Windows host.
yeah,
So you can always extract everything. Like if you have very critical stuff that you don't want to lose, you can always get it back. And also, like if it fucks up, like you can also do regular snapshots. Meaning you can copy your VMs. You can say, hey, that VM I want to like duplicate it, and I want I want to install on something else, and one of them I want to install something else.
yeah.
So
It seems
very
very
flexible.
useful.
It's a powerful tool, but again, virtualization in itself is only useful. It's only a tool. It's not a means to an end. It's I mean it is a means to an end. It's a tool. It's just a tool. Virtualization alone does not really do anything for you, right? It's a means to an end. It's like, oh, I want to develop on in an isolated environment. You can do virtualization. But literally if all you want to do is just browse the web, like I don't know, like you just want to browse the web all day and that's all you use your computer for. Honestly, you don't need a VM. What do you what why would you use a VM for that? There's no
Yeah.
need, right? Any closing thoughts maybe before we wrap up?
This was very interesting, and I am very happy I decided to to join this.
Well, I'm glad you found this enriching. Definitely, this is kind of the purpose.
Yeah. Now I actually want to take notes and start learning about this. Because normally I'm the type of kid who dreads taking notes.
Right, but you can see, like, we didn't necessarily go very fast, but there's a lot of stuff to unpack.
There is.
Right.
I was surprised at how much stuff I thought I knew, but in the end, it was a lot more than what I had thought.
Right. This is first. I know that feeling where you feel like you know something, you feel confident about it, and then someone asks you a question or explains something to you, or you're like, I didn't know anything until then.
Yeah. It's an experience.
Mm-hmm.
And it's a fun experience. That's the thing.
Yeah. I mean, for me too. The reason I start this channel is precisely to share my love for computer and computer science with as many people as possible. That's why
Yeah.
I'm like, even professionally, I am a network instructor. Like, I teach computer science professionally, and I just love doing that.
Well, you do a good job of doing it too.
Oh, thank you. I appreciate.
You're welcome.
Well, on that, I think this is it. Thank you very much, Trailmix.
It was a pleasure.
Yeah. See you next time,
Thank you.
probably.
Hopefully. And hopefully I won't have any more needs to disappear.
Hopefully, we can prepare a little better. Yeah.
Yeah.
All right. Thanks. Bye.
No problem. Bye.
Well, Chad, that was really cool. Now give him the test. If he fails, he dies. That might be a bit extreme. The test was just running the VM, you know? But yeah, what did you think, chat? Zeiss, what did you think about the class? Because, so if your goal is to ever run like your own home infrastructure, you're probably better off doing virtualization, because then like you have a very big flexibility in what you can do. Side advice to take notes. Yeah, that's true. I mean, if you're take notes like your life depends on it. That does make sense. But then we should have told him beforehand, right? You warn him that there is going to be a deadly test at the end. No? That's how you separate the wheat from the chaff? Anyway, thank you very much for joining me today. We will have another class very soon on VPN, and I'm very much looking forward to that one. In fact, I've been practicing it a little bit. The VPN class is not simple. There's a lot of content to unwrap, so we probably won't go too fast. Like, I'm probably gonna do it sometime early next week. We will wait a few days to, like, especially because I don't want our friend Trailmix here to feel like we're going too hard on him. You know, one class at a time, right? Anyways, thank you very much for watching, and I'll see you all soon.